Ladies and gentlemen, esteemed guests, faculty members, and my dear students, it is with great pleasure that we gather here to inaugurate the National Space Day celebration at the Indian Institute of Technology, Kanpur. This momentous occasion marks a significant milestone in our nation's journey through the cosmos. Just a year ago, on 23rd August 2023, a historic feat was celebrated, the successful landing of the Chandrayaan 3 lander on the lunar surface. This achievement not only made India the first country to land near the southern pole of the moon, but also opened up new avenues for scientific discovery and collaboration. Hence, the theme for today's celebration, India's role in space science, wherein we explore the regional growth opportunities via industry and academia participation. To begin with, let's inaugurate our event with the timeless tradition of lighting the lamp. Allow me to extend a warm welcome to our esteemed dignitaries, whose presence graces this auspicious beginning. First and foremost, I kindly invite our beloved professors, Professor Amitesh Umar from the Space Department, Professor Pankaj Jain, the head of the Department of Space, Professor Kamath, the head of the Aerospace Engineering Department, and Professor Braj Bhushan, the Deputy Director of IIT Kanpur, to please come forward for the ceremonial lighting of the lamp and then proceed towards the dais. We also invite our Honorable Chief Guest, Dr. Subba Rao Pavluri, President of SIA India, Chairman and MD of Anand Technologies Limited, to join us on stage to light the lamp. As the lamp shines bright, marking the beginning of our celebration, I request Professor Kamath to welcome our esteemed chief guest, Dr. Pavluri, to the dais with a small token of our appreciation. We are deeply honored to have you here with us today, sir. Thank you. I now invite our distinguished keynote speaker, Srimati Nigar Shaji, the project director of India's first solar mission, Aditya L1, to the stage. We are immensely grateful and honored to have you here, ma'am. Kindly accept our small token of appreciation. We are delighted to invite Professor Sandeep Sahijpal, a renowned astrophysicist and planetary scientist from the Department of Physics at Punjab University, to the podium. We are excited to have you here with us today, sir. Thank you. I would like to extend a warm invite to Professor M.C. Uttam, the Director of ISRO University of Pune, Space Technology Cell at Savitribai Phule Pune University, to the stage. I also request Professor Pankaj to welcome Professor Uttam to the dais with a token of our appreciation. Thank you for gracing this event with your presence, sir. I now welcome Professor Ajit Kembavi from the Inter-University Center for Astronomy and Astrophysics, Pune, Vice President of the International Astronomical Union and the Principal Investigator of the Pune Knowledge Cluster, to the dais. Thank you for joining us with us today, sir. Finally, I would like to invite Mr. Tushar Jadhav, the co-founder and CEO of Manastu Space, a pioneering space technology company, to the podium. We are excited to have you here, sir. Kindly accept a small token of appreciation. We request all the esteemed dignitaries to kindly take their respective seats on the dais. So now we have here a stellar lineup of eminent speakers who will share their insights today on space exploration, technological advancements, and our nation's space endeavors, followed by an engaging panel discussion on India's contributions to the advancement in space science. Finally, we will end our celebration day with an enchanting evening of solar and sky observations. Without further ado, and to ensure a collaborative beginning, we will have our welcome speech delivered by the heads of Department of Space and Aerospace Engineering. First, I would like to invite Professor Pankaj Jain, the head of the Department of Space, to the podium to deliver the welcome speech.
Thank you, Sandhya. So let me start by welcoming all of you to the National Space Day celebration. I'm delighted to see so many young minds among us today. The Space Day is being jointly organized by the Department of Space, Planetary and Astronomical Science and Engineering and the Department of Aerospace Engineering. I am particularly grateful to our distinguished guests who have taken time out from their busy schedule to grace our event. It's a matter of pride for all of us that India has made a successful landing on the moon. It is truly a matter of joy for us to be celebrating this major historic event. I truly admire the dedicated work put in by ISRO to make this a reality. It is an honor to have scientists from ISRO among us who will be presenting their work for us today. Space is rapidly catching the imagination of everyone. Many companies, startups are entering this domain and doing very impressive work. We will have a glimpse of that in the industry exhibition today. Many education institutions are also starting coursework in space. We have started a new department that I just mentioned. It's called the Department of Space, and it's devoted to imparting education in all aspects of this field. We are currently offering MTech and PhD degrees and a minor program for all undergraduate streams. We are also planning to offer a joint minor with Aerospace Engineering Department and in future a joint BTech. I also want to add that research in space is currently in nascent stage. Hence, it presents considerable opportunities. Some of the goals are perhaps clear. and we'll hear about them from the speakers today. However, I particularly want to mention that it may offer many opportunities which no one may have thought about so far. And it's up to the imagination of the future generations, namely all of you, to uncover these possibilities. With this, I want to end my welcome speech, and thank you very much.
Thank you, Professor Pankaj, for your inspiring address. I would now like to invite Professor Kamath, the head of the Department of Aerospace Engineering, to the podium for his welcome address.
Good morning and namaskar. Thank you, Sandhya. Our chief guest, Dr. Subbarao, our officiating director today, Professor Brajbhushan, Professor Jain, eminent speakers and panelists for today, dear students, colleagues, ladies and gentlemen. It gives me great pleasure to welcome you all on behalf of the Department of Aerospace Engineering at IIT Kanpur for today's National Space Day program. While this day commemorates the successful landing of the Chandrayaan 3, we would also like to celebrate the spirit of exploration, the excitement of science, and the rigors of technology development that the space evokes. As the eminent Russian space scientist Tsiolkovsky famously said, "Earth is the cradle of humanity, but we cannot live in the cradle forever." So we have come a long way from Sputnik to Starliner, and closer to home from Aryabhatta to Aditya, from sounding rockets to Gaganyaan. And as our space ambitions of Bharat, India grow, we as an academic institution need to prepare and inspire future generations to take up these challenges. So as one of the steps, as Professor Jain also mentioned, we at the Aerospace Engineering Department are closely working with the Department of Space to offer a more space-oriented curriculum. This will help expand. We also hope that this will expand to other departments. Incidentally, the Aerospace Department itself moved from the Department of Aeronautical Engineering to Aerospace Engineering in 1991, keeping in mind that we need to bring in a more space component into our curriculum. And we are continuously working on upgrading that aspect. So, of course, while we have come a long way, as I just mentioned, of course, the road ahead is also extremely long and arduous. So, we are by no means, as Professor Jain also mentioned. So, today's program will highlight some of these achievements as well as some of these challenges that lie ahead for us. So, I congratulate and thank my colleagues and our students who have worked very hard to put together this program for all of you. So it promises to be a very exciting day for students, our colleagues, students, and so on. I also thank our very eminent guests and speakers who have come from far away, and from our own colleagues here who are giving us their valuable time and sharing their profound knowledge with us. So I once again welcome you all for this grand celebration of space, science, and technology. Jai Hind.
Thank you, Professor Kamath, for your insightful words. I now welcome our esteemed chief guest, Dr. Subbarao Pavuluri, President of SIA India, to deliver the inauguration speech. Dr. Subbarao, being the founder, chairman, and MD of Anand Technologies Limited, is known for his exceptional contributions to the field of aerospace and has been recognized with the prestigious Aryabhatta Award and the title of Distinguished Fellow from the Aeronautical Society of India. He has over 40 years of experience with the ISRO, where his insights and visions have been instrumental in shaping the future of the industry. So please join me in welcoming Dr. Subbarao Pavuluri by giving him a warm round of applause.
Namaskar to all of you. For all youngsters, our blessings. We have a very distinguished dignitaries on the dais and my dear students. A small correction to what she said. I was not in ISRO for 40 years, but I was associated with the space program for more than 40 years. There is a lot of difference between being in ISRO and working for the space program. For example, today, all of you are part of the space program in this country, in one way or the other. Normally, what it said is, the space itself is so much of that, anantam. Antariksham anantam. That's what it said in there. It means to know that type of anantam, which infinity, our prayatna, our activities also should be much more than what is normally required for any usual activities on that part. All of you are becoming the part of that activity on that. And I'm glad that IIT has both the thematic part, that engineering part of it, and also space sciences here in this. In the space sciences part of it, I'm sure students from your families itself, you must be knowing that the space has become the part of the Indian culture. It's a part of Indianness. Bharatiyata completely embedded with the space technologies from the very, very beginning, not today, thousands of years ago. Perhaps all of you must be following something like every day, what we call that in Telugu, in my language, called Panchangam, almanac. It shows the planet, it tells the planetary positions, and based upon the planetary positions, what is the auspicious time, what is good muhurta, what is not the auspicious time, what is durmuhurta. All this part of it, every housewife in India, they look into that almanac every day, and that's how the space technology and output that generated from the space has become the part of our life. I am glad that Professor Jain explained to me about a way that space sciences particularly is growing in IIT Kanpur. All of you have looked into what happened so far in this ancient India and what can be done with another technologies. I don't say modern technologies because the technologies we had thousands of years in this country itself is very, very, deep technologies that we have on that. Those days, our Maharshis or whoever looked at the planetary positions and the stars' positions. That's how, if you look at Mahabharata or Ramayana, the date of birth of either Rama or Krishna or anybody always mentioned with reference to the position of the planets. So that means position of planets, nakshatra, the Kotami, where it has happened, that means this can't be changed. And whereas when it comes to English calendar, the things have been changing a bit here and there and that part of it. So that's why what we had is a perfect mathematics, perfect engineering, perfect deduction of the planetary positions that have been used to find out what we are in this country. This happened from the thousands of years. So I request all our students to also to look into what we have the ancient texts like Surya Siddhanta, or very, very many texts that we have it. We have 18 Puranas and we have also 18 different texts on the astronomy itself in this country on that. So I request you also to look into that and then build it with the modern part of it. See, most of the things we did earlier was by intuition, but today we're trying to do the same thing with instrumentation. So the difference between the intuition and instrumentation, suppose you combine these two, then we become Viswagurus. What we were earlier, and we have to become the Viswagurus also in future. This is with reference to whatever ancient part of it. When we come to the present status of, today we are gathering here to celebrate the National Space Day. Why it happened? Perhaps I would like to will touch upon what it is briefly, and later the architect is here. She will explain to you more about how the entire program has taken that. And she is the combination of Lakshmi, Saraswati, and Durga, all put together. She made it happen in the part that way. When we received the independence in 1947, I'm not sure how many of us were really excited about the independence, because many people in the remote areas may not be knowing what the independence was. But when we were landing on the moon, every Indian looked at the TVs to see what's happening on that. And the prayers from every temple, every church, every mosque. part of that entire mission. So there was so much of excitement that everybody had in the country. And that happened, and that has to be the same spirit of science must continue with each one of you on that. When we started the space program nearly about 60 years ago, we can say that time it was a startup. There was a great man like Vikram Sarabhai who found out that something can be done in this country itself on that, should be done in this country on the space program. So when they envisaged the space program, we had nothing. We did not have any kind of education-related part of it in that area, or we didn't have any instrumentation, we didn't have the experts. But still, you can look at their dhairya, the way they were looking at the entire thing that India should compete in the space technology with the rest of the world, and you must make use of space technology for the development of the nation. That was the envision, that space program that Vikram Sarabhai and the sequence of people who laid the foundation for this program all over. And today, we launched many satellites. The satellites are different types, as you must be aware of that. There are operational satellites, technology satellites, then planetary missions, like the various things. While this is being developed, parallelly, we also developed the launch vehicle programs in India. That how we started with the Rohini experimentation with, just to find out what's happening in the atmosphere. So therefore, some rockets to send it and read that what's happening, and some telemetry, some data coming down on that, and see how the monsoon is affecting this entire country, how the monsoon is being created over India. That's how the experimentation started on that. In fact, we are also sharing this data with the rest of the world, with who are the other people who are interested in this area. And subsequently, we developed the SLV-3, and you must be knowing that the very famous man, President of India, Abdul Kalam, was the project director for that. So there are failures, successes. There's nothing like a failures in the space programs as such. Every program, what we go through, will teach us a lot of lessons. So learning lessons is always augmenting our knowledge, which means there are going to be a series of successes that comes into the programs, and with all these programs. And subsequently, we developed PSLV, Polar Satellite Launch Vehicle, to put the satellite into the LEO's orbit. That's where, we first started with the IRS program, Indian Remote Sensing Program. Earlier, NASA developed a program called Landsat series of programs. So we wanted to do something very similar like that. So we developed Indian Remote Sensing Systems on that. Because that was the time when we envisaged what's known as NNRMS, National Natural Resources Management System. That is, whatever the resources that we have in the country, both natural resources and also the augmented resources part of it should be brought into one system. That's called National Natural Resources Management System that was envisaged. And as a part of that, we need to get a lot of data. The data normally has to be the today's data, that is updated data to be obtained. To obtain that kind of data, we have the satellite side, because satellites gives you the present data, what is available on the ground. So therefore, this data should become the part of the National Natural Resources Management System. That's for our planning part of it. And parallelly, we also started building up the GSLVs to launch the satellites, for the communication satellites into geosynchronous orbit. And when that comes through, the communication to reach to the last mile connectivity in the villages, etc., that's how we envisaged in that. First satellite, we started working with a Ford company elsewhere in America, and we started learning what it is. Then we built our own satellites on that. And all this, the greatest achievement that we have is the cryogenic engine too. Because to energize the entire thing, to put the satellite into geosynchronous orbit, we need to have the engines like the cryogenic engines. Even this cryogenic engines part of it, we learned it afresh. And while doing so, of course, many people who are jealous of us also put a lot of obstructions. They did that. But still we come out of that, and we did that. So what all this happening is the faith in ourselves. That is the faith we have in ourselves. That's what we have to, all of you should cultivate on that. Swami Vivekananda always used to say, faith in yourself, the confidence part of it. Once you have that confidence and faith in yourself, you can achieve anything that is required in this, for any human being on that. So that part is important. That's why I request all of you to develop the faith part of it. See, what happened in our generation was important was somehow to survive in a society. So education is the means for that. Then after getting into a job and all that. But all of you, today I'm sure, well placed in the society, with your parents doing well. Don't look for just an employment somewhere else. Look for what is to be done with your ability, with a premier institute like IIT giving the knowledge to you, what can be done, how you can become employers. For example, we have a gentleman here. He comes from IIT Bombay. He had a company which does here a lot of employment, a lot of ideas he has. He started building up the satellites on that. And similarly, in fact, this is what I've been discussing with the Professor Jain Saab. We think of an idea, we can give that idea into a shape. That shape can be, we have Rupu and Rekha, both can be given to that. And using that part of it, we can always look at what can be done. That's how the new innovations can be created. If you look at the villages, every villager, somehow or the other, every time they do the new innovations in the village, whether the illiterates or literates, they try to give something new always. In the same fashion, with your education background, you can do much more wonders than what it is on that. So I request all of you to look at more on that. And instead of my talking more and more about that, as an entrepreneur, since I mentioned about the industry part of it, earlier the space program means in India only ISRO. Today, ISRO has become the part of the space program, and all of us also can become the part of the space program as individual entities or with the companies being built as a part of that. For example, if you look at the national needs today, perhaps we need hundreds of launch vehicles, hundreds of satellites in order to assess every small square millimeter of the land that what we have, both in terms of resources and also building up the infrastructure. And similarly, communication to reach to the last man in the country, that, the effective communication. We have been building a lot of roads, that the physical infrastructure being built, highways are being built. But we also have to build digital highways. When you build the digital highways, the satellite is the best answer for doing that activity. And while doing so, a lot of ideas. One need not be in an urban areas like Kanpur or Lucknow or Delhi. One can be in a village also. Once we have the digital highways, then entire thing can be connected the rest of the world. In fact, I know many entrepreneurs who have been doing the work in the villages and giving the data to the American companies and European companies on medical transcriptions, or many ways of doing things on that. So therefore, building up the digital highways is also one of the important things that one has to do on that. And for doing that, a lot of ideas can be floated. Even the satellites can have different types of payloads, and what kind of payload you think so? So some of you are interested only in the science related. What kind of payloads are to be built only exclusive for science related experiments, and what can be done for utility part of it, and how the entire thing can be envisaged. A lot of ideas can be created on that. I'm sure all of you will come up with your ideas. And never be employee into another company. Be an employer. Means that needs a lot of guts, dhairya. Then also we need to have a lot of ideas. I'm sure all of you have that, and you can do that. Thank you. God bless you all.
Thank you, Dr. Subba Rao, for your encouraging words, which have indeed ignited our passion for exploration and have inspired all the students. Thank you once again for gracing us with your presence and sharing your valuable perspectives. Now I request Professor Pankaj Jain to present a token of appreciation to Dr. Subba Rao. Okay. Now going forward with the program, I would like to invite Srimati Nigar Shaji, the Project Director of India's first solar mission, Aditya L1. She will be sharing insights on our space science program, highlighting the achievements and findings of Indian space science missions, the technological challenges faced, and the exciting future endeavors in space exploration. Please join me in welcoming Srimati Nigar Shaji. Let us.
faculty members. Okay. Yeah. Faculty members and my dear students, and warm greetings to you all. First of all, thank you very much for this opportunity to be here on this esteemed institution and also to interact with you all, especially students, because interacting with the students or talking to students will always rejuvenate me. So that gives me a lot of energy to move forward. And with this, okay, before moving on to the Indian Space Science Program, let me dwell little on the ISRO's journey. And also it's a very good initiative from the government side to declare the day of Chandrayaan landing on the moon as a National Space Day. This creates and enriches awareness in the public so to know about or enter into space science and technology opportunities. So let me move on. Yeah, to start with, because you students are here, you may be already knowing, but let me begin with, okay. First, let us see what led us to the space age. So it's the human quest for knowledge and also the inborn human curiosity to know the unknown. That is the basic instinct of the human nature, which led to a lot of innovations and what we are today in a civilized world. So that is the basic reason for us to go to the space age too. And next is the sense of adventure. See, going to space is always adventurous, and developing technologies to make that adventure happen, it is still more adventurous. So a sense of adventure and exploration that is inspired some others. And the next comes the national interest. It's protecting your own nation and having a pride, because always if you have seen this space technology, it's again a cutting edge technologies which gives you a soft power in the world. So because after our landing on the moon, see, our soft power in the world arena has really enhanced. So this is one of the reason. And next, this leads to, because once space was a luxury, but today space applications and technologies have become a necessity, and today you cannot live without space applications, because whatever the mobiles, whatever you have, it's space is part of it. So it now contributes more towards the economy of the country. And but today we have only 2% of the world economy. Our Indian space economy is contributing, and this, it's government's initiative to make it 10% in another decade. So, and this leads to jobs and cutting edge technologies. These are all the reasons which led us to the space age. Okay, moving on to the journey of ISRO. I like, because once after independence, when India was struggling to beat the poverty, one great visionary, Professor Vikram Sarabhai, he dreamt, as well as he is so convinced that we should be second to none in using the space technologies for the development of the country, as well as improving the standard of living of the people of the country. So at that point of time, the space was a luxury, and many eyebrows were raised that for a country, poor country like India, space development is a must. But in spite of that, this visionary, he made it possible to start the Indian space program, and because of that, we are today, we are not really second to none in using the space technologies for the development of the country, as well as we are into the space adventures also. So as we set the goal for having the space application for the development of the country, our journey initially was towards making space applications, so especially in Earth observation and communication. We started our program parallelly with first making the spacecraft, so we had some initial spacecraft development program, followed by we have the remote sensing as well as the communication. We call it IRS-1A and INSAT-1A. These are all the beginning of our programs which contribute towards the Earth observation and communication. So Earth observation, if you take a lot of applications at agriculture, we have urban planning, forest mapping, ocean studies, even weather and disaster management. So today we have thematic satellites. We have a ResourceSat series, which looks for water and land resource management. And also we have a fleet of spacecraft for ocean studies. We have fleet for weather studies and meteorological, and all these will contribute to disaster management. And also for urban planning and strategic applications, we have cartographic missions. And we have today resolution of the order of sub-meter resolution. We have spacecrafts today of the order of sub-meter resolution. So that way in the remote sensing area, where almost all the ministries of the government are utilizing our data, and it is being we have a lot of applications in the area of remote sensing, and we have both developed optical as well as microwave remote sensing, IR bands. So we have almost, we can proudly say we are second to none in remote sensing. And next comes the communication. See, communication mainly those days where the communication which cannot reach the remote corners of the country, where the terrain is so bad and where the ground communication networks are not possible. So there, these satellite communication plays a major role, and we have a lot of applications on teleeducation, telemedicine. Even we have a high throughput satellite which have a greater bandwidth. So we are so very sustainable and self-sufficiency in communications too. Once we achieved this self-sufficiency, the basic space technology, a space application for the country, we moved our attention towards navigation. So those days we wanted to have a navigation of our own. Because as you know, GPS, GLONASS, and all the countries have their own navigation system, and they are global too. But we don't get higher accuracy data from those navigation spacecraft. So we started our own navigation system, NAVIC system. We have now a series of NAVIC application. So it is, government is planning to have the receivers in your mobiles also to receive the Indian NAVIC system too. So this, as you know, navigation has its own applications. Having achieved all these things, we started our journey into the space science. So space science, though we have started purely for the space science applications in 2008 onwards, but earlier also, we have been doing space science as it's only as a piggyback payloads in different spacecrafts along with the remote sensing applications. We are having a piggyback payload. So having done that, then moved on to total into space. Today at ISRO, to have all these programs, we have 5 verticals of management. One is, the first thing is you need instruments for the applications for remote sensing, transponders for communication, and for space science, we have a lot of instruments to study the atmosphere as well as aeronomy or solar physics or astronomy. So the instrument development, this is done, that is the wing which does the space application. It's led by our Space Application Center, Ahmedabad, and we have all the payloads development will be happening under this segment. And next comes the space infrastructure. To carry these payloads, we need a system or a system which has a structure and which can maintain the pointing and stability and communication to the ground. All those things that support the payload, we need systems to keep these payloads in space. We need systems. So that's done by space infrastructure. segment that is led by UR Satellite Center, Bangalore. And next, once you make the spacecraft, to transport the spacecraft to space, we need space transportation. That is the rocketry or the launch vehicle, which is done by the lead center by Vikram Sarabhai Space Center. And we have a fleet of vehicles supporting different payload capabilities. And then comes, to have all these, we should have launch bays and the related human resources and the technical infrastructure. So we have a segment of capacity building, so that takes care of all these activities. And now, having successful in space science, navigation, communication, and remote sensing, we are now into human space program also. And you may be aware of our Gaganyaan program, and we wanted to venture into space tourism. And also, it is mainly not only the space is the ultimate goal, but to develop technologies to take man to space, finally to the moon, Mars, and colonize the other planets. So we have that program, that is one another segments. So these are all the major 5 segments by which we manage the entire program of Indian space program. Okay, so coming to, so like what led to the space age, we have to see why we need deep space missions or the space science missions. The one is, the first thing is to answer the fundamental question. At all of you, and some part of, some time in your life, you might have asked these 3 questions. Who are we? Where did we come from? And where are we going? This is the basic and fundamental question everyone like to learn and like to answer, and we are still prodding over that. So almost all the astronomy missions, everything what we want to study in the universe. So that is the reason. And next is the search for life elsewhere. So are we alone? So that is the another question which continuously boggles us. So that you see, as on today, in the entire universe, see if you take universe, you have billions of solar system in your own Milky Way galaxy, and like that millions of galaxies in the universe. And the universe is expanding, and we still today we don't know, other than us, is there any other living creatures in the universe? That is one quest. Next is, because as we more and more innovations, more and more improvement in standard of life, and we are exploiting our resources on the earth, and we are exploiting the earth also. So the human greediness, it's led us to colonize other parts of the solar system, so thereby preventing the human species from extermination. That's one of the reason which we go for deep space missions. And also whether we can, whatever the resources from moon or Mars which can be, or the energy, how we can generate and substantiate the energy demand of the earth. So that also search for resources to substantiate earth resources. And all these also have really changed our understanding of life and our universe. Because having worked in this space science missions, what I learned is we are very insignificant if you compare in the universe and the number of galaxies and the number of solar systems, and we are a tiny dust in the earth. So that way we are very insignificant, but we are also very significant that other than us, nobody has, no other planet, no other system has life. So that way we are both insignificant as well as significant. And I request everyone to be having understood this. It made me more humane and more humble. Okay, coming to the ISRO science-based experiments, because we started our journey with making of Aryabhatta. So incidentally, Aryabhatta, we started with only a science payload, which science payload for X-ray astronomy, aeronomy, and solar physics. And further, we have different payloads during our development. And we have as a piggyback payloads concentrated more on X-ray astronomy and studying gamma ray burst, as well as the energy distribution of ions, electrons by RPA. So, and also we have X-rays polarimetry to the spectral characteristics of the cosmic sources. So like that it went on. And parallel to the development of the spacecrafts, we had, because that space transportation also is very important. So we have started from SLV-3 and we slowly grow. So as we grow, that's what we, the launch vehicles, the capacity to carry the payload mass also increases. If you see, for SLV-3, we have carrying capacity of only 40 kgs, and which improved to 150 in ASLV. And today we have our workhorse of ISRO, that is PSLV. It can see, based on the varied orbits, the payload also changes. So nominally, so a sub-GTO, it can handle around 1,500 kg. And we have GSLV Mark II, and which can carry up to 2,200 kg for sub-GTO orbit. And also the highest launch vehicle, GSLV Mark III, which can carry about 4,500. So today we are totally a very indigenous way. We can have our own launch vehicles, spacecrafts, application, everything. So more than we need to depend on other countries' transportation vehicle only for spacecrafts, which is weighing more than 4,500. We also have communication spacecraft which weighs about 6 tons. So for that we need to go for a launch vehicle from the other nations. But we are in the progress of making parallelly the spacecraft technologies as well as the launch vehicle technologies. So after this, after achieving self-sufficiency in all our applications, our journey of pure space science spacecraft started in 2008 with Chandrayaan-1. That was the initiative from the ISRO to have, and also it is start of the interplanetary exploration. And we had Chandrayaan-1 followed by Mars Orbiter mission. Then we had an astrosat, which is totally multivalent astronomy. It is a dedicated astronomy observatory in space. And we have Chandrayaan-2. And you know, last year was a very, very successful year for ISRO. And also we had 3 successful and very important space science missions, Chandrayaan-3, Aditya L1, and XPOSAT. So that's what, coming to Chandrayaan, which is just an orbiter, because we were only well versed with the mission strategies for a low Earth orbit or a geostationary orbit. The first time we are going to another planet, so the mission strategy and mission technique and the flight dynamics, what is involved is really, it was very new to us. And so with the Chandrayaan-1, we could master that flight dynamic strategy to insert the spacecraft into the attractive field, within the field of another planet. First it was the moon. So it was only Chandrayaan-1 was an orbiter, and it has all the remote sensing instruments. Then we went with Mars Orbiter mission, because at that point of time, we had a PSLV as the only launch vehicle what we had. So it was a very innovative way we designed our spacecraft to constrain the entire spacecraft well within the mass or payload capability of PSLV. But you know, it has to travel a distance of for 400 million kilometer, and the fuel what we have to carry is really huge. And apart from that, what instruments are what the spacecraft also built to that. So it was really very challenging and very interesting spacecraft to master these interplanetary missions. And we had this MOM on November 5, and followed by we had the astrosat mission. It was really, even today it gives a lot of scientific outcomes, and a lot of papers are being produced on this astrosat. It's a multivalent total astronomy spacecraft, and that's a low Earth orbit at 650 kilometer orbit spacecraft. Followed by we had Chandrayaan 2, and which was a failure. We failed to land on moon, and we learned a lot of lessons from that failure. That propelled us to have a successful Chandrayaan 3, and followed by we had the first maiden solar observatory at Sun Earth L1 point. It is at the L1 point, which is about 1.5 million kilometers from the Earth, and followed by the XPOSat. Is apart from NASA, it is the only, we have the only only spacecraft which is very dedicated to X-ray polarimetry studies. Okay, coming to the science outcomes of Chandrayaan 1. Chandrayaan 1, it's really a pinnacle of ISRO's international cooperation, because in Chandrayaan 1, India has 5 payloads and all the remaining 6 payloads are from the other countries, NASA, ESA, Russia, and Bulgarian Academic Sciences. And the total science outcome was it's only for the compositional studies of the surface, and also especially we had an impact probe also in that, so it impacted on the South Pole, and it is mainly to find out the presence of the water molecules in the permanently shadowed regions on the moon, and we were the first to detect water on the moon with this collaborative payload. And also because we had a good camera which does the entire moon mapping, so the 3-dimensional mapping, we could get the craters of interest from these cameras, and also to study the lunar environment, because the final goal was to find out or to have a human habitability on the moon. So we need to study the environment hazard, because outside the Earth there is a lot of radiation, because our magnetic field is protecting us from all those radiation and the plasma effects. So it is mainly to study, is there a place on the moon which is less hazardous in the case of radiation, micrometeoric impacts, the temperatures and dust storms, such as. So these are all the major objectives with this 11 payloads, and the life was around, it stopped working after some 8 to 9 months. The 1 year we had the mission. Coming to Mars Orbiter mission, this because it was mainly a technological demonstration mission, so we could have only a 10 kg of payload in this and a small 5 payloads. So it has provided only the discovery-wise, it's the presence of suprothermal argon in the exosphere of Mars, and also because of the highly elliptical orbit, it's around 80,000 kilometers. So we could generate a lot of the full images of the Mars and produce a Mars atlas. This is the science outcome on Mars Orbiter mission. Next comes the astrosat. So astrosat is multi-wavelength. It is in IR, visible, and X-ray. So it is the simultaneous, it has the observation on these 3 bands, and we have 5 payloads, and here we have a good collaboration with the science institutes of the country, because the 3 payloads are from TIFR, and UVIT payload is from IIA and IUCA, and ISRO payload was SSM. And its main objective is to have a determination of black hole masses, the study of galactic binary, and that mainly the star formation and its evolution. These are all the main objectives of this astronomy, and also it has a huge number of papers and findings. So it was the first to detect FEV photons, so from the galaxy AUDFS01, and also we could make a deep survey of Andromeda galaxy, and it has discovered also the X-ray polarization of the Crab Nebula. So if you see, it has mainly, if you can see this, yeah, I think that picture is not visible, because we could fuse the images from JWST, the James Webb telescope recently launched on Sun Earth L2, And with AstroSat data, we could identify because AstroSat has a UV payload, we could identify the star-forming regions of the Stephens quintet. And also, if you see the AstroSat, when you compare with the galaxy, NASA, that spiral galaxy, we could have a much more finer structures to be revealed because of this UV high resolving power. It has of the order of 1.2 arc second to 1.5 arc second as the resolving power. So coming to Chandrayaan 2, because the lander has failed in landing, and we have in orbiter, but it was even today it is operating, and we have a lot of payloads, and we have the first payload, and we have organ 40 observations and mapping of sodium, but it's all in the remote sensing. And we have the camera, which was the highest resolution in the world, and even NASA was taking images from that for planning their further landing on the moon, on the landing site. And we also used this camera images for to load because Chandrayaan 3, we had a good mapping of the places where we wanted to land on South Pole. This camera images are only utilized for Chandrayaan 3 landing, because landing, what we do is in advance we will decide the terrain, because the lander, as you say, that lander legs, because moon is full of craters and we cannot land in a place where the crater and the lander will topple and it has. So we should identify the landing regions in advance that will be loaded in advance in the lander systems, and our navigation cameras and navigation system will be mapping the surface and matching with the landing region, whatever already loaded. Then based on that, the lander craft will be maneuvered, and finally it will land on the place. We will identify a by 4 kilometer by 2 kilometer, a big stretch of land. So within that, based on this navigational feasibility, it will land on any place on this stretchable mat. Okay, coming to Chandrayaan 3, we had a propulsion module. Because why we had a propulsion module means we have the rocket capability of GSLV Mark 3. It can only leave us at a sub-GTO orbit. So this propulsion module, which carries the lander and rover to the moon orbit. So then the lander, followed by, we had a rover, which is of the order of mass of 26 kg, which the mission is planned for 1 lunar day, that is 15 Earth days only it is planned, because we don't have the technology with us which can withstand the temperatures of the order of minus 150 to minus 200 degrees centigrade. So unless nuclear energy source is there, we will not be able to survive that cold. So we had only a 1 lunar day as the life of this Chandrayaan 3. And if you see the orbital, this one, we will be increasing the velocity of the spacecraft so that around 11 km/s per second, so as to go out of the Earth gravitational pull, and then we will reduce the velocity to get it attracted towards the moon orbit, and finally we reduce the orbit to a circular orbit of 100 by 100 km, and from 100 by 100 km we will try to descend and land on the surface of the moon. If you see the descent, we have in the rough braking, because what it means is we have to travel the distance, but finally by the time it lands on the moon, its horizontal and vertical velocity should come to 0. Otherwise it will, because Chandrayaan 2, what has happened was we couldn't reduce the velocity to 0 by the time it is about to land on the moon. That's how it crashed on the moon. So here the sensors, which gives the range, as well as the velocity, Doppler velocity meters, which give the velocity, and we have to maneuver with our propulsion system. So the reduction of velocity from the orbital velocity to the 0 velocity, and the range, what we have to travel, and the time, all the 3 things to match it, and the navigation should be such an excellent, then only we'll have. That's why it's so tricky, and everybody celebrate this landing because the technology is it's very, what do you say, it depends on how much simulations you do, how much in advance you anticipate the failure cases and simulate and everything we have to do. How well you anticipate, because Chandrayaan 2, we failed to anticipate such a failure case. That's how it crashed. So that mainly depend on the simulation and the performance of the reaction control system as well as the sensors and the actuators. So we had in Chandrayaan 3 also lander. We have payloads, and mainly the payloads for measuring the surface plasma density as well as the thermal properties and the seismic behavior of the surface. These are all the payloads what we had in lander. And in orbiter also we had a payload which is an experimental payload which senses the signatures of a habitat wave. From moon it will view the earth and senses the signatures for the have, so that we can use it further to study the exoplanet or is there any other planet which has a life. So such a signatures will be taken from viewing the earth. And also we have rover 2 payloads. So it is the chemical, this is the first time in the South Pole the chemical composition is being investigated, and recently we had a good publication in Nature and on the surface composition of the lunar regolith. So these are all the major outcomes of the Chandrayaan 3. We had a good South Pole temperature profile, and we had elemental compositions and the plasma studies of all the surfaces of the moon. Then comes we had next the Aditya L1 mission. It's the first solar observatory. I'm very happy to be leading the team for this ISRO's maiden solar observatory at Sun-Earth L1 point. Here mainly we started this mission with the 2 objectives. One is to, though sun is so familiar and so appears to be quiet, so it has a lot of processes, and it has solar flares, solar wind, solar coronal mass ejection, mainly to study the process of evolution of all these solar events. And also because as I told, it was once a luxury, today it is a necessity, and we have lot of space assets, and we ourselves have more than 50 plus spacecrafts in space. And all these CMEs or that solar radiation, you might have heard a lot of news about the geomagnetic storms, so which is very harmful to our spacecraft. So to have a good space weather model, this spacecraft is being, so that a better understanding of the space. So in future, we will be able to have the identification, the trigger, so that we can save our space asset. These are the 2 major objectives with which this mission we have planned, and it almost covered. It has a particle in situ particle observation instruments, as well as we have a UV, X-ray, as well as on the visible range we have instrument to study all the major events of the sun, that solar flares, CMEs, and solar wind studies. And in this, it was quite challenging to reach at L1, which is 1.5 million kilometers. This was flight dynamic strategy what we had adopted to reach L1. So we have mastered, in addition to entering into the other planet's atmosphere, and we can have a spacecraft at L1, which is a vantage point to observe the sun 24/7. That's why we have gone for this sun at L1 point. So we have the science payloads, and from the institutes, this is from, the first payload is from Indian Institute of Astrophysics. It's mainly for the study of coronal studies. And we have from IUCA, we have solar ultraviolet imaging telescope to study the UV radiation as well as solar flare studies. And we have 2 X-ray payloads to study the solar flares in the X-ray region, and a magnetometer, as well as the 2 particle analyzers. These 3 payloads together will be useful in giving us a warning for the geomagnetic storms, early warning for geomagnetic storms. And comes the X-ray this is XPOSAT. This is the X-ray polarization payload. We had two payloads, X-ray spectroscopy and polarization. So it's mainly to study it is an important tool, that emission process from the binary stars, pulsars, and black holes. This spacecraft is also, so soon we will get lot of hope, we'll get a lot of science outputs from this spacecraft. Then coming to the future missions on space science, we have Venus orbiter mission. This is to study the surface, subsurface, as well as atmosphere and the plasma environment. Because as you know, the Venus is called the twin sisters because both Venus and Earth almost formed in the same time, but the conditions are so different, and Venus is has a hostile environment. It has a surface temperature of around 450 degree and the pressure of 90 bar, like that. So it's not livable condition. So there is a school of thought that once Venus was habitable and it has become like this. So in order to study whether Earth also, future Earth, how it will become, this study will help. And we have another payload for the study, for the aeronomy study, Earth aeronomy studies. And we have a collaborative mission with Kennes, France, for the climatic studies and the ecosystem stress. And an ExoWorld mission, which is to study the atmosphere of the exoplanets, planets from the other galaxies and the solar system. So I have a study on this because it is something like a JWST, a miniaturized version of JWST. And we have one more moon mission for a collaboration with the JAXA for again to measure the quantity of water ice on the South Pole. And we are also planning to have a Mars landing mission. This is because we have already mastered the landing technology in a planet without atmosphere. Mars having a thin atmosphere, to master that technology, landing technology in a planet with thin atmosphere, that is the major objective of this Mars landing mission, and also to study the Mars environment for future colonization. So with all this, our program further, we wanted to have big lunar exploration roadmap, as well as parallelly with the India Bharatiya Antariksh Station like ISS. So these are all the two major roadmap plans we have. And finally, by 2040, we wanted to have the moon on, man on moon. So this is we have lot of exciting programs in front of us, and very interesting and adventurous to work. And I think the future of ISRO lies in all your younger generation, and your participation, academia and private participation. Without that, all this is not possible. Just by ISRO, with all the very excited plans what we have, it is not possible without your participation. Requesting all your participation, all from every one of you, and my best wishes for all your future endeavors. Thank you. Thank you.
Okay, so very relevant to this. So I have two lines. चंद्रयान भेजा तुमने, चांद पे पानी खोज लिया, हम सीमित धरती तक नहीं रहे, सबको यह संदेश दिया. With these lines, I would like to thank you, Srimati Saji, for your inspiring presentation on the Indian Space Science Program. We deeply appreciate your time and effort in sharing this valuable knowledge. Now, if anyone want to ask any question, you can ask to Ms. Srimati Saji. Questions? School students, if you have any question, you can ask. Feel free to ask. So give the mic. Here in the front seat. Front seat.
Hello ma'am, I am Gaurav from Doon Public School. I am a 12th standard student, and actually I was asking about the sonic levitation. Can we use the technique to as a landing technique in other planets, the sonic levitation? Actually, I have my own research papers related to that. Can we talk on that further, if you want?
Okay, the levitation wise, we have not worked because actually levitation will be very useful when we want to have a habitat establishment in moon. There we are planning where the vehicle movement, see when you have lot of some few habitations to move the materials and this, we need to have a transportation system. So in places of that, we think these levitations will be more useful.
Hello. Thank you very much, ma'am, for your very motivational talk. I have a question regarding to the LUPEX mission. Means what role, significant role ISRO is going to play, and I know that you are going to place a lunar lander over there, a rover. So, what are the future prospects for the researchers in this particular mission?
Yeah, because already we have the Shiva Shakti point and we wanted to, because you know that water ice is only on the South Pole because of the permanent shadow of the moon. So all the countries are planning to have establish the habitation, or you have, because apart from the habitation, we wanted to have moon as a base for further going to the space, because as you know, when we want to travel to Mars or beyond, the present available chemical propulsion, it's very difficult to go and come back. So this as a base, so that we can have a refueling stations, we can build our own rockets there. So the 3D printing is going to play a very major role, and also to have the oxygen generation, water generation there. So these are all the things, because the next mission what we are going to have a collaborative mission with JAXA, that is to really measure the water quantity in the South Pole, what is available. Further, we have one more mission for the sample return mission. So followed by that, we have to establish the communication navigational network, so that for the habitat or the man to go there and come back, these are all so that's how our the plan is.
In this regard, what are the future prospects for the researchers, like?
Yes, very well, because you need to have lot of research on the biology, space biology plays a major role, how we can have the plan and this one. And also because lot of research is going on, because as you know, the lunar regolith, if you see, it doesn't have any binding on this one. So how to make structures of the lunar regolith which doesn't have a binding energy, how to make, so that prospect, lot of that research is going on, and also the electrolysis of water, oxygen, all those, so that it should be self-sufficient you have. So these are all the research areas which we need to concentrate finally if you want to have a habitation.
Okay, thank you very much.
Why Aditya mission is launched at only at L1 when there are 5 Lagrangian points?
Okay, 5 Lagrangian points. Actually, you can have at L1, L4 and L5 also. L2, where it will be, say, you know the 5 Lagrangian points, because L1 has the advantage that 24/7, as the Earth moves, the spacecraft also moves. So it will never fall under eclipse. It will be always viewing the sun. So that is the vantage point for the solar studies. L5 also you can have. Actually, it is better to have a spacecraft both at L1 and L5, so that L5 to L1, the solar events, by the time L5 point, it takes some few days to come to L1 point. So very well in advance we can, we will know about the storms and the solar events. And L4 is not very useful. It can also view the sun. And L2 is not at all useful because it is on the other side of the Earth. It will be useful for all your deep space studies. If you see, JWST is launched on Sun Earth L2, and our exoplanet also we are planning to have it on L2.
Thank you, ma'am.
Good morning, ma'am. Ma'am, I am a biotechnology student. So, ma'am, I would like to ask, is there any chances for me to join a space science project as a biotechnology in space science?
So biotechnology has a lot of application in our Gaganyaan because a lot of microgravity experiments. To join ISRO, there are two ways. One is we have our own institute, Indian Institute of Space Technology. You can join there, and with a good CGPA, you will be directly absorbed to ISRO. And apart from that, we have almost every Feb, we'll be calling for, we'll conduct tests all over India. We'll announce, you can be watching the ISRO website. And based on your test performance, you will be called for an interview and you will be taken. But the vacancies are little limited only. It's not like software industry, we don't have vacancies.
Okay. Thank you, ma'am, for such insightful answers. Now I request Professor Kamath to present memento to Srimati Shaji. Thank you, sir. So there are two lines. गर्जन करता धरती से मैं, धधक रहा आकाशों में, दौड़ रहा मैं अंतरिक्ष में, भारत का अभिमान हूँ, मैं चंद्रयान हूँ, मैं चंद्रयान हूँ, मैं चंद्रयान हूँ. With that, I now welcome our beloved Deputy Director, Professor Brij Bhushan, whose insightful leadership and progressive outlook has propelled IITK's space endeavor to new heights. To deliver the director address, please join me in welcoming Professor Brij Bhushan to the stage.
A very good morning to all of you. I see the bright, colorful lights scattered everywhere in this room. So warm welcome to all the budding scientists, the budding citizens, the bright citizens of India, who has captured approximately 95% of this hall. During our childhood days, the best memory that I have is of a song which read Chanda Mama Dur Ke. I don't know, in the current generation, I'm sure this is no more the song that you would remember. But the distance between us, our imagination, and Chanda Mama, that got reduced thanks to ISRO. Okay, and we started celebrating different kind of successful missions that they conducted. Two things besides two things which primarily makes us proud worldwide. One is our association with cricket, second is our association with the Bollywood, and in the science technology domain, something that makes us very proud is the overall achievement that the Indian Space Research Organization has given us. Every time we would have a successful mission, we as the citizens of India would be glad, we would be delighted, and we feel as if each one of us has contributed to it. So here is the time. I was very glad when Shaji ma'am's last question that you encountered was somebody asking how can I join ISRO. And as a student of biotechnology, I want to contribute to the space mission. So I think this successful organization of National Space Day could have nothing so great as somebody showing that, okay, I am in a given domain, now I want to contribute to this domain. My special vote of thanks to both Dr. Subbarao sir, Shaji ma'am, both of you. special vote of thanks to both our colleagues, Professor Pankaj Jain, the head of the Department of Space, and Professor Kamath, the head of the Department of Aerospace and Engineering. Both of them have been instrumental in organizing this grand show. One of the themes that the Government of India declared for the National Space Day, one was that this is not going to be celebrated as a single day, this would be celebrated as a month. So we have the full month of National Space Day. And the most beautiful aspect of it, the government says that we will have something called touching humanity while touching the moon. That's the tagline that the Government of India has given to the celebration of the National Space Day. And when we talk about touching humanity while touching the moon, Saji ma'am gave you a whole lot of issues in our life where our day-to-day things are somewhere connected to the space and science technology program. I don't know if you remember, on one of her slides where she was talking about plasma analyzer, I found Papa, right? So there are interesting keywords, the acronyms which would attract you, somebody from biotechnology suddenly saying, okay, let me study it. I got attracted to Papa there in this slide. Another interesting thing also, I think, that those of you who would pursue science and technology, there has been a big emphasis on STEM. Science, technology, engineering, management. That is what the government says, that there has to be a thirst towards STEM. The school students, all those of you who are sitting here, they are supposed to be part of the STEM program. But I would also request you that look at the counter view that comes from mostly Europe, which says that the STEM program has to be deeply connected to SHAPE, where SHAPE, this SHAPE has to do with social sciences, right? Dr. Subbarao and I were just having a chit chat that there is supposed to be a deep connect. Dr. Subbarao sir talked about some of the ancient sages. Now the sage sitting in the ashram can visualize of the space, can make fine calculations. Thousands of years before we had institutionalized the space research. Right from there till now, when India is contemplating a manned mission, and I don't know how many of you are aware of this, most of those who participate in the manned mission, participate means go up in the space, they become very prone to depression. The symptom of depression is very high in them. And there are a whole lot of studies basically you will find on this. So everywhere, right from the biotechnologist who showed interest how to join ISRO research, okay, I am sure irrespective of the discipline of study, all of you would find a deep connect with the space mission, all kinds of technologies that are being taken forward, and the associated field. Even stuffs like documentation would become extremely important. How to document science literature is a challenge. How to chronologically make it so simpler so as to make it part of the school curriculum. Okay. Talking something big is at some other level, but then you have to bring it down to the lowest level so that right from the preliminary stage of schooling, you can infuse a scientific temperament in the child. Irrespective of which discipline the child goes into, one should definitely have a scientific mind, a scientific temperament, a very logical mind, a critical mind, which will not accept the things the way it comes, but would rather analyze it and then show acceptance towards it. This would lead to refinement. This would lead to all kinds of changes that we envisage in the years to come. I must express my sincere vote of thanks to all the school authorities who allowed their students to come here. And thanks to see all of you smiling here, right, that you came here. This is a golden opportunity. I would urge that do come to IIT Kanpur campus. We would love to have you on the campus. Come on various days. If your school wants, you can directly get in touch directly with the institute or with the concerned department where you want to visit, and we would definitely facilitate your visit to different labs, different facilities that we have. So thank you once again, and my special gratitude to all the luminaries who traveled long distance to showcase our collective strength of science and technology in this hall. Thank you.
Thank you, Professor Brisbhushan, for your inspiring and thoughtful address. Your words have truly set a positive and motivating tone for our event. Thank you, sir. I now request all the dignitaries to move forward to inaugurate the space exhibition in foyer area of L19. Students will be keep sitting here, only dignitaries will go. कहाँ पर है तुम बोल देना पोस्टर प्रेजेंटेशन कहाँ पर है हाँ ओके poster is not here poster is somewhere else so all the students there are announcement for you so for the all school students your packed high tea will be provided to you in L19 here only in this hall so along with that you will be given a piece of paper where you can write all your question which you have in mind and you didn't ask okay and there will be a drop box you can put that slip in that drop box okay our volunteers will tell you more and write write your write your name school name and class along with the question okay so I'll speak in Hindi आप सारे स्कूल स्टूडेंट्स को इसी L19 एरिया में यहीं पर L19 हॉल में आपको पैक्ड हाई टी मिलेगी है ना और उसके साथ में आपको एक प्लेन पेपर का स्लिप मिलेगी उस पे आपके पास जो भी क्वेश्चन है ओके उसमें आप लिख सकते हैं जो भी आपके दिमाग में आ रहे हैं कोई क्यूरियोसिटी कोई थॉट ऑल द क्वेश्चंस और वो क्वेश्चन एक ड्रॉप बॉक्स में बाहर रखा होगा उसमें डाल देना है प्लीज़ साइलेंट एंड लिसन टू द अनाउंसमेंट प्लीज़ साइलेंट मेंटेन द साइलेंस प्लीज़ मेंटेन द साइलेंस ओके सो आफ्टर दैट डन so you all can now move to the space exhibit to the space exhibition outside this lecture hall in that L19 foyer area. Now you all can go. Slowly, don't create the chaos. Move one by one, okay? As
Welcome back, students. I hope you enjoyed the exhibits that were outside. So, meanwhile, I request Satyender. He has some interesting poetries to share to entertain yourself till we start the next session. So, I'll hand over the mic to Satyender.
Okay, so this poetry is in Hindi only, okay, और ये पोएट्री एक्सप्लेन करती है 11 स्पेस मिशंस 11 स्पेस मिशंस जो कि अलग अलग स्पेस एजेंसीज ने अलग अलग प्लैनेट और प्लैनेटरी मून्स पे भेजे हुए हैं। ठीक है, सुनिए इधर। तो इसका टाइटल है हे मानव। हे मानव तुम धन्य धरा पे अगणित ही इतिहास रचे, आए जीव कई धरती पर, मतलब मास एक्सटिंक्शंस। ठीक है, आए जीव कई धरती पर, कुछ तो है विचित्र तुम में जो बिना पंख आकाश उड़े। स्पुतनिक 1 द फर्स्ट सैटेलाइट, स्पुतनिक 1 भेजा तुमने, अपना परचम लहराया और वहाँ से फिर अंतरिक्ष दौड़ का युग आया। पहला मानव भेजा तुमने, फर्स्ट मैन ऑन द मून, पहला मानव भेजा तुमने, ईगल मून की भेंट हुई। ईगल जो लैंड किया था मून पे उसका नाम था, ईगल मून की भेंट हुई, गौरव ऊंचा हुआ मनुज का, साल 69 धन्य हुआ 1969। चंद्रयान भेजा तुमने, ये तो सुना ही है अभी, चंद्रयान भेजा तुमने, चांद पे पानी खोज लिया। चंद्रयान 1 ने पहली बार बताया था कि जो है चांद पे पानी है पोल पे, है ना। चंद्रयान भेजा तुमने, चांद पे पानी खोज लिया, हम सीमित धरती तक नहीं रहे, सबको यह संदेश दिया। पाथ फाइंडर, क्यूरियोसिटी, परसिवरेंस, ये मंगल पर जो रोवर्स हैं उनके नाम हैं। पाथ फाइंडर, क्यूरियोसिटी, परसिवरेंस, ये सब मंगल पर हैं दौड़ रहे, क्या मंगल पर जीवन संभव है, हम यहाँ बैठकर उनसे सार निचोड़ रहे। मानव ने मैसेंजर भेजा, मैसेंजर मिशन जो कि मरकरी पर भेजा गया। मानव ने मैसेंजर भेजा, मर्क्यूरी को भी देख लिया, पार्कर सबसे तेज रहा, वीनस से भी भेंट किया। शनि जुपिटर कैसे बसते, मानव जिज्ञासा के आगे। शनि और सैटर्न एंड जुपिटर 2 पे एक मिशन भेजा गया था जो कि दोनों प्लैनेट्स को विजिट किया था। तो शनि जुपिटर कैसे बसते, मानव जिज्ञासा के आगे, तब कैसीनी भेजा तुमने जो इन दोनों को मापे। न्यू होराइजन भेजा तुमने जो कि प्लूटो पर गया था। न्यू होराइजन भेजा तुमने, प्लूटो का अहंकार भी चूर हुआ, आगे बढ़ गए उससे फिर उसको पीछे छोड़ दिया। सोलर सिस्टम तक ही ना सीमित, बाहर भी है अस्तित्व मनुज का। व्योजर भेजा था तुमने, जो बाहर है वो खोज रहा, हे मानो तुम धन्य धरा पे अगणित ही इतिहास रचे। धन्यवाद। नाउ सेटल डाउन।
Dear students, I request you to please maintain silence, and I hope you have submitted your question slip. If not, kindly submit it to the volunteers who will be coming around.
आपको जो स्लिप दी गई है, एवरीवन साइलेंस, साइलेंस, मेंटेन द साइलेंस। आप सबको जो स्लिप दी गई थी आपके क्वेश्चंस लिखने के लिए, वो वॉलंटियर को दे सकते हैं। अब आपने क्वेश्चन जो भी लिखे हों वो वॉलंटियर को हैंड ओवर कर दीजिए। वॉलंटियर्स हैं यहाँ पे बीच बीच में। जो स्लिप दी गई थी उसमें आपने क्वेश्चन जो लिखे हैं वो वॉलंटियर को दे दीजिए। वो इधर आ जाएंगे और वी विल आस्क दैट क्वेश्चंस। We are about to start the program. Everyone, please silent. Please maintain the silence. We are about to start the program. Please maintain the silence. We are just about to. Should we start now? Please settle down quickly. We are about to start the program. कुछ अर्जेंट है? कुछ अर्जेंट है? स्टेज पे हो। Welcome back, everyone. Please settle down. Please maintain the silence. Please maintain the silence. Please silent. Please maintain the silence. Welcome back, everyone. I hope you all had a refreshing tea break and enjoyed the space exhibition and poster session. As we reconvene, it is my pleasure to invite you all for an engaging session that promises to expand our horizons even further. Today, we have the honor of hosting a distinguished scholar whose contribution to the field of space sciences and technology have been nothing short of groundbreaking. Professor Sandeep Sahispal. He is a renowned astrophysicist and planetary scientist from Punjab University with a rich academic background that includes a PhD from Physical Research Laboratory, Ahmedabad, and postdoctoral research at University of California. Professor Sahispal has significantly contributed to our understanding of origin and evolution of our galaxy and the solar system. Today, Professor Sahispal will be sharing his insights on the realms of space sciences and technology, answering the profound questions that have fascinated humanity for centuries. The origin and evolution of universe and of course the technological advancement that have opened new windows into the vast expanses of space, allowing us to uncover secrets that were once beyond our reach. Without further ado, please join me in extending a warm welcome to Professor Sahispal.
Hello. Am I audible to everybody? Okay. Revered faculty members, scientists, treasured students, good morning. Thanks for inviting me and giving me this opportunity for this lecture. So what I'm going to do is that I'm going to give you a basic flavor about what is space sciences and technology all about. Okay? And why do we have to do this thing? Means can we live without it? Okay, now there is a basic thing that somewhere in Africa, over the last couple of million years, one species evolved, that is Homo sapien, and that is us. And that started spreading out. Because the basic reason that we have a thinking brain, we started thinking about everything. We eventually evolved from hunting to agriculture-based civilization. And if you want to do agriculture, you should have a calendar. And if you want to have a calendar, you should understand sun, moon, planets, stars. So that is how our journey starts. And because of the curious nature, we want to actually understand everything. We want to understand how this whole thing came into existence, the fundamental question. In fact, it covers actually every bit of science. We want to understand the origin of this universe. How did this universe originate? What actually happened? How did the universe evolve? How are the galaxies formed? How are the stars born? How the stars live? What goes on inside the stars? What are the various nuclear reactions that produce all the elements? The periodic table that you see in your 9th, 10th class books for the first time. The question is, where were all these elements produced? And it is amazing that these elements are mostly produced inside stars by nuclear reactions. There are thousands of nuclear reactions which have been identified, which produces everything. Then we want to understand how the stars actually eject this material into space and how the planets are formed, how our solar system was formed. How come we have life on the third planet from the sun in our solar system? What is so specific about our planet Earth? Then, is there life elsewhere? That is what we want to address. So there are thousands of questions, and space sciences is one particular branch of science where we try to actually scientifically address these questions. There could be alternative way of speculating whole thing. You can do philosophy and something else, but we follow a scientific approach. And the scientific approach starts with astronomy. If you were to broadly classify space science and technology, what are the various components of space science and technology? We have astronomy, astrophysics, planetary science, atmospheric science, climatic studies, weather forecasting, and then there are totally technical issues related with telecommunication and satellites, remote sensing, defense and security of nation. Actually, the people who are working in these particular fields right now, wherever they are, whether it's a research institute or university, they at some point of the time, maybe when they were of your age, they got fascinated by this thing. And ultimately, they are working in one of these fields. Okay, for instance, I am working in the second and the third field. Most of the time, I am working in these particular areas. We cannot afford to work in all these areas because these are now extensive areas. Only if you are very good in all the sciences, only then you can work in these things. And in fact, there are definitely some scientists working in ISRO who are competent to actually handle these things. So that is a remarkable thing. So what I am going to do is that I am going to act like a salesman. You consider me as a salesman of this thing. Okay? So we have a quite good infrastructure in India, our own infrastructure in these fields. Now it is up to you whether you want to pursue your career in this particular field. Okay? In case if this thing has struck to your mind any time in your life that how did this whole thing came into existence? So this is the way, this is the path, how you are going to do that. Okay, so now, what is astronomy? Astronomy is basically an observational science. In the ancient times, our ancestors used to use just naked eyes. Then thanks to Galileo, Hans Lippershey, we started using telescope. Now you name any wavelength in the electromagnetic spectrum, we have telescopes. We have ground-based telescopes, we have satellites in space, and you have a complete information about the entire electromagnetic spectrum that we are building up. When I say we in this particular talk, it means the entire scientific community, okay? Now, so the idea is to observe the universe. One thing is that you observe the universe in the entire electromagnetic spectra, going from radio waves, you have infrared waves, you have visible, you have ultraviolet, you have X-rays, you have gamma rays, okay? This is the standard thing that we have been doing in astronomy. Apart from that, in future, what is going to happen is that there is some entity, a very fundamental particle referred to as neutrino. Okay? It's not neutrilla, something close to that, but it is neutrino. In future, what is going to happen is that neutrino is going to open another window of astronomy. Right now, things are working up. Okay? There are some problems related with neutrino. There is a third axis which deals with the gravitational wave. So you have basically three entities which are trying to tell you how the universe works. They are trying to talk to you. One is the visible, the entire electromagnetic spectrum. The other is the neutrino, which I have told you. Now keep on thinking what that neutrino is. Maybe at this point you do not know, but in future you will know. And the third is the gravitational wave. Okay, so what do? You observe the skies. You observe everything, whatever facilities you are having. We have a very moderate type of a telescope in our department. That is the fellow. It's an 11-inch Schmidt-Cassegrain telescope. So if you try to take photographs of some nearby object, that is what you see. These are all the photographs which we took with our telescope. We can do spectroscopy of stars, something like that. Very rudimentary thing. It's so much rudimentary, it cannot be qualified as a research. But then you have to train the students. So that is required. This is what you do when you are having a very moderate type of telescope. If you have very powerful telescopes, just like some of the people, researchers who are sitting over here, they are operating and they are working on those. This is what you get. This image that you see over here, this is the place where the star formation takes place. The stars are born. The sun also was formed somewhere in the past. The stars are born in this type of environments. These environments exist in interstellar space. These are referred to as molecular cloud. The matter exists in the form of molecules. Mostly hydrogen, then you have a series of molecules. Now, if you see over here, there are certain regions. For example, if you pick up these darker regions over here, these are places where the density of these molecular clouds are very high. These are the places where the star formation commences. Now, the idea is very simple. A pocket of this gas undergoes a gravitational collapse. The gravity simply squeezes that matter and a star is born. The star is not something different from what you can think of as a pocket of gas. It's after all a pocket of gas. So the matter shrinks, a pocket of gas, and the star is born. A little bit of gas and dust is left around it. That evolves into a planetary system. So the formation of planetary system, star, is a very generalized thing. This is not the only place where the stars are born. You have millions of trillions of such places in the entire universe. This fellow is named as Carina Nebula. It has nothing to do with the Bollywood actress, but the name is Carina Nebula. Okay, it's quite interesting thing. Those of you who are familiar with what you refer to as the Balmer series line, hydrogen atom, the redness is because of that. The greenness in this figure is because of some oxygen line, spectral line. If you see any blueness, that is because of Rayleigh scattering, the same phenomena why the skies are blue in color. Okay. Then you have array of other pictures. I have taken couple of pictures just to give you the idea about the whole thing. This is something when the star actually explodes. Now, what is actually a star? I told you that a parcel of a molecular cloud undergoes a gravitational compression and a star is born. Now, when do you say the star is born? Deep inside this star, a thermonuclear fusion reaction starts. What does it do? It converts hydrogen into helium. The star is mostly hydrogen. It converts hydrogen into helium. This is the most exothermic reaction that you can think of in nuclear physics. So a lot of energy is released. That energy is transferred to the surface of the sun or any star, and that star starts shining. That the plants tap that energy, you consume the plants, and then your brain works. Somewhere around at 20 watts. That is a typical power of your brain. It is working at that time. So we are straight away extracting energy from that thermonuclear reaction. There are parts involved in that, but that is how the whole thing is working. Okay? It's not less than a miracle. The stars are actually configured in what we refer to as galaxies. You can see this thing. A typical galaxy can have hundreds of billions of stars. Billion means Arab, एक अरब, 200 अरब, 300 अरब तारे हो सकते हैं. You in one particular galaxy. Then you have billions of galaxies in our universe. This one is Orion Nebula. Some of you may be familiar who are following astronomy. Even with the good binoculars, you can see it. Not the colors, but you can see it as a white cloud pattern. Generally, at your age, people get interested in these things, so they start using binoculars. The idea is that in astronomy, we observe the skies in multiple wavelengths. We use the entire electromagnetic spectra, and we grab the information. There are standard laws of physics that we use to extract the information. Like, for example, Stephen-Boltzmann relation. Some of you are familiar. Wien's displacement law. You might have heard about it. At 12th class, you generally come across this thing. So we use that information and decode the entire manner in which the matter is distributed in our universe. In astrophysics, what we do is that we try to understand how this entire universe works. Because the astronomy has given us the adequate information about the universe. Now it's up to you to model the universe, to understand how the universe was created, how the universe evolved, and how the things have been going on. Now what I'm going to do is that I will give you a single glimpse of information which contains the entire evolutionary history of the universe. Majority of us believes now that there was an event known as a Big Bang, which occurred 13.7 billion years back. Billion means Arab, एक अरब. तो 13 अरब साल पहले, almost 13 अरब साल पहले Big Bang occurred. Before that, there was nothing existing. Nothing means literally nothing was existing. That is what we think, majority of us. But there are alternative hypotheses for that. But this is what our present understanding is. This Big Bang created space-time, the fabric of space-time. What you refer to as space and a time, it was created by that. And now what will happen is that it will start from a singularity, a mathematical singularity, almost a point, of less than even a point. So that fellow started creating space-time, and it created matter and energy. Initial temperatures of the universe were very high. Then as this universe expands, the temperature started falling down. Now all the protons that you have in your body, anywhere in this universe, in stars, planets, or anywhere, all those protons got created right in the beginning. Right in the beginning, after the Big Bang, majority of the protons were created. So if you ask your protons that are in your body when you were created, the chances are that they will tell you that they were created after the Big Bang, 13.7 billion years back, almost around that time. So that old is the material that we all of us are living with and living on, okay? Then there was an era when all the electrons that you are familiar with in this universe, that exist in this universe, they got created. I'm using a vague word of saying created. There is a technical word known as freeze out. Let us not bother about the technical details here. So think about it that electrons and protons, they were created after the Big Bang. They are so old. After that, there's an era when the hydrogen and the helium got its abundance to 75 to 25% by mass. So hydrogen and helium acquired this abundance after the Big Bang. There was a particular era. All the elements heavier than carbon, including carbon, nothing was produced after Big Bang. Okay, so if you, let us say you were living at that time, imagine a hypothetical situation, you were living at that time, you will not have any heavier elements, including carbon and beyond carbon, only hydrogen and helium. So where were all the elements produced? So we have something which we refer to as the formation of the galaxies. The galaxy formation started forming just after the Big Bang. There was a particular time interval. So you have the formation of galaxy. With the hydrogen and the helium, you can form some clouds, big clouds. These clouds will collide with each other. It will result in the formation of bigger clouds. You have much, much bigger clouds. This is the beginning of the formation of the galaxies. We refer to them as proto-galaxies. Within the galaxies, the star formation commences. The first generation stars were born. Within these stars, the nuclear reactions commence. All the elements that you are familiar with, up to iron, majority of these elements are produced by fusion reaction, nuclear fusion reaction. Because of the fact that these reactions are triggered by heat inside the star, they are referred to as thermonuclear fusion reaction. This is something which comes even at 9th class level, nuclear fusion reactions. So those elements, all the elements up to iron were produced by that. Beyond iron, there were some other type of nuclear reactions which involves neutrons. So neutron-induced reactions produce rest of all the elements up to uranium. So if you want to know where was gold produced, where was silver produced, where was anything heavier than iron produced, it was produced by neutron-induced reactions. You may be amazed to know this thing that at this particular time of our understanding, there are thousands of nuclear reactions which have been identified, which would have produced all the isotopes, whether they are stable or radionuclides, in our periodic table. When the stars produce all these elements, the stars die after its age. The age could vary from 3.5 million years to something like billions of years. depending upon what is the mass of the star. Some stars explode as supernova, some stars eject their mass as red giant stars, then there are a wide range of other stars. When the stars eject their mass, whatever elements they have produced, it goes into the interstellar space, and from that, next generation of stars are born. The cycle repeats and repeats and repeats. For the last 13 billion years, this cycle has been going on. We are witnessing a continuous recycling, rechurning of the material. It is not that the entire material is recycled. Some of the material stays as black holes, neutron stars, or white dwarfs. That is something which is left, okay? Some of it may contribute further, but that is what is left. So the moral of the story here is that we have a beginning. 13 अरब साल पहले हमारी beginning हुई, और जो तारों ने सारे के सारे elements बना दिए हैं, उससे क्या लगता है? क्या हमें ये लगता है कि are we star children? Yes, technically we are star children. Okay, they are our actual ancestors. If you start going back, tracking down, I'm not saying genetic ancestors, I'm saying elemental ancestors or nuclear ancestors. So that way we are brothers and sisters. Okay, not at a genetic level, but at a nuclei level, we are brothers and sisters because we are sharing a common ancestry. Okay, now there is a critical thing, and that is something very important for us. That is the birth of our solar system. Our solar system was formed 4.5 billion years. 4.5 अरब साल पहले हमारा सोलर सिस्टम का गठन शुरू हुआ था. वो कैसे हुआ? There was a molecular cloud. It collapsed because of its own gravity. It resulted in the formation of our solar system. Now, there is an interesting thing here. If you see the material from which our solar system was formed, hydrogen is 70%. वो शुरू में 75% था, वो reduce हो गया, helium बढ़ गया, और Z देखो, Z क्या होता है? अब एस्ट्रोफिजिसिस्ट क्या करते हैं? कार्बन से लेके यूरेनियम तक जितने एलिमेंट्स हैं ना, उनको इकट्ठा करके कहते हैं ये मेटल्स हैं. आपका अगर कंडेंस मैटर फिजिक्स वाला होगा वो नाराज हो जाएगा. बट दिस इज हाउ वी ट्रीट द थिंग्स. ओके, वी डोंट डिस्क्रिमिनेट एनीथिंग फ्रॉम कार्बन टू यूरेनियम. वी ट्रीट देम एज मेटल्स. Z represents that. You see this Z, it has gone up. How? क्योंकि जितने भी रिएक्शंस हुई हैं स्टार्स के अंदर, उन्होंने ये Z बना दिया, हैवी एलिमेंट्स बना दिया. इसीलिए हमारी बॉडी के अंदर कार्बन है, ऑक्सीजन है, नाइट्रोजन है, फॉस्फोरस है, सल्फर है. क्योंकि अगर हम बिग बैंग के बाद बने होते शुरू में गैलेक्सीज में, तब ये कुछ था ही नहीं, तब लाइफ भी नहीं होनी थी. इफ यू आस्क ए फिजिसिस्ट व्हाट इज लाइफ, physicists will say life is, it involves some reactions involving carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. कार्बन की कैटनेशन प्रॉपर्टी यूज करेंगे तो कार्बन कैटनेट करते करते बना देगा सारा कुछ, ग्लूकोज, सारे उसके डेरिवेटिव्स, प्रोटीन चेन्स, सब तरह के डेरिवेटिव्स. इट कम्स बिकॉज ऑफ द कार्बन कैटनेशन प्रॉपर्टी. इट्स एज सिंपल एज दैट. दैट इज द ओनली लाइफ फॉर्म दैट वी आर फैमिलियर विद. सो यू हैव इट हियर. You cannot think about having it there. Maybe somewhere here. अब एक जो गलती बड़े बड़े लोग करते हैं, वो ये करते हैं, what they confuse the formation of our solar system with Big Bang. नहीं है. Big Bang हुआ था 13 अरब साल पहले और ये हुआ है 4.5 अरब साल पहले. ये recent event है. This is a recent. Of course you say 4.5 अरब को recent कह रहे हो, लेकिन वो recent ही है अभी. तुम्हारे को बनाने में टाइम लगेगा. The DNA, the evolution of DNA takes time. तभी आगे इतनी स्पेशल चीज बनेगी. We people are very special. It was emphasized in the last lecture by madam. There is a contradiction actually. We are actually nothing compared to the vastness of the universe, but on the other hand we are special. Okay. What is planetary science? Planetary science को अलग सा सब्जेक्ट नहीं है. लेकिन what we do is that planetary science में जियोलॉजी आ जाती है, कुछ और चीज़ें, केमिस्ट्री आ जाती है, तो एस्ट्रोफिजिक्स से हम थोड़ा सा उसको अलग ट्रीट करने लग जाते हैं. तो अदरवाइज इट्स एक्चुअली एस्ट्रोफिजिक्स. What do we do in planetary sciences? This is the system which we are having apart from the sun. We have inner planets. These inner planets are rocky. You can stand on them. You have a surface over which you can stand. The outer planets are giants. Jupiter, Saturn, Uranus, Neptune. And these are gaseous. Why is it solar system? Why is that the solar system is like that? Now, if you start asking this question, why is it that the water is there on liquid water is there on Earth? उसीलिए शायद लाइफ है हमारे प्लैनेट के ऊपर, अदरवाइज नहीं होती. लिक्विड वाटर अर्थ से निकाल दो, खत्म है. अर्थ से आप तीन चीजों में से कोई भी एक निकाल दो. मैग्नेटिक फील्ड अर्थ की निकाल दो, एटमॉस्फेयर निकाल दो, लिक्विड वाटर निकाल दो, लाइफ खत्म. It becomes almost like Mars. Okay, so we may not repeat, we should not actually repeat what happens there on Mars. Mars was also somewhere like that, Earth, long time back, but it suffered a disaster sometime in its history. Why is it that all the planets are going around the sun in the same plane, in the same direction? क्या खासियत है? और inner planets rocky क्यों हैं? और tiny क्यों हैं? Outer planets giants क्यों और gaseous क्यों हैं? And what about other family members like comets, asteroids, everything? When you talk about pure sciences में हम जानना चाहते हैं ये सब कुछ बना कैसे, evolve कैसे हुआ, एक एक ग्रह कैसे evolve करा. We want to understand everything. और इनके satellites हैं, Jupiter, Saturn के 200 से ज़्यादा satellites हैं. We want to understand them. This is what we want to do in pure sciences. Then there is another branch which was again mentioned by madam in the morning. We are basically explorers. याद है ना हम शुरू कहाँ से हुए थे? Somewhere near Africa. ठीक है? Africa से originate हुए Homo sapien. Now there is not a single square inch of land on earth where we do not have our own footprints. Is this going to continue in the space? Now we live in an era where this thing is going to continue to outer planets or inner planets or the satellites of outer planets. What would be this situation? Imagine a situation something like 1,000 years in future. So 1,000 साल के बाद सोचो क्या होगा. Think about what it would be like after 10,000 years. We have almost a long time in front of us. Are we going to move out? That is what our destiny is, because we write our own destinies. We are going to set up space stations far away, to maybe colonies on some particular places like Moon and Mars to start with, and maybe we will move out. It depends. And we have infinite resources available. Asteroids, comets, you have infinite resources available. There is no problem as far as the resources availability is concerned. Are we talking about science fiction? Okay, let it be science fiction. There is another thing. Person who is basically an astrophysicist or planetary science, जो भी इस category में आ जाता है, उसको science fiction movies अच्छी लगती है. So if you have interest in watching movies like Martian, Interstellar, Star Wars, Star Trek, it's good. You are on the track. You will very soon join us, okay? Because we need a bigger community. We are living in a subcriticality mode as far as our community is concerned. Community like people who are working in these fields. We have to actually enlarge that community. So you people will do that thing. Okay, now gather all the information that we have done so far by sending spacecraft to different planets, satellites, by analyzing meteorites, by analyzing Earth, chemical composition, सारा कुछ करके ये कहानी बनी. ये कहानी ये बनी 4.5 अरब साल पहले. There was a molecular cloud. We think that there was a supernova, it exploded. Supernova explosion हुआ. उससे जो shock wave आई, उसने एक cloud को compress कर दिया. And this cloud was actually rotating. Now there is a standard law in physics that you know at 12th class, that is conservation of angular momentum. आप लोगों ने देखा होगा सर्कस में एक लड़की ऐसे करके घूम रही है, फिर हाथ ऐसे लेकर आई तो वो फास्ट रोटेट करने लग गई. If you ever wonder why our planets are going around the sun in the same direction on the same plane, that is conservation of angular momentum. Now the matter started falling on this disk of gas जो rotate कर रही थी. Maximum matter center में चले गया, जिससे sun बन गया. That is how you explain the sun and the rotation of the sun. ये जो मैटर घूमता रहा आसपास, Ye matter initially it was hot, it was gas mostly. Now you believe in the power of thermodynamics. Thermodynamics is an entity which most of us are afraid of. Aati hai na jab thermodynamics, but that is a very powerful subject. And actually everything is powerful in all the sciences. We should not discriminate. Thermodynamics predicts that if the temperature drops, the gas can condense into dust particles. So as the temperature dropped, the dust particles started going around the sun. These dust particles started hitting each other by a mechanism named as coagulation. ये शायद आपने chemistry में सुना होगा. Coagulation. जो मलाई जमती है, that is a coagulation process. जो इकट्ठे हो जाते हैं चीजें. By coagulation process, the small rocks or pebbles started forming. छोटे छोटे पत्थर बन के सन के आसपास घूमने लग गए इस डिस्क के अंदर. These pathars, these pebbles started colliding with each other. It resulted in the formation of boulders of rocks. These boulders of rock further collided with each other, resulted in the formation of planetesimals. So there was a time when the planetesimals formed everywhere in the solar system. These planetesimals further collided with each other and resulted in the formation of planets. And that is what we are having. Why all the planets are going in the same direction and almost on the same plane? Thanks to this disk. We refer to this as the accretion disk. It's a very simple approach proposed by somebody whom you may be knowing, Laplace, the famous mathematician. Long time back. Of course, he didn't give the entire recipe of forming the solar system, but he proposed an idea which is what you are seeing. This is the final modern version of what it is. Do you think that this is the final picture that you know? And whatever I told you earlier, जो Big Bang के बाद सारा कुछ हुआ? नहीं. एक कहावत है, science is provisional. Provisional मतलब मैंने ये बोल दिया, सर ने कुछ बोल दिया, मैडम ने कुछ बोल दिया, आप लोग कहोगे नहीं ये गलत है, ये ठीक नहीं है, मैं ये आइडिया देती हूँ, जब मैं ये आइडिया देता हूँ. That is how the science works. Science believes in democracy. If anyone can give a better argument, a better explanation, that person will propose the idea. Okay, that is how the science works. Science remains provisional at any given time. Keep that thing in mind. ठीक है? अब एक बड़ी सीधी एक चीज क्लियर करनी पड़ती है, क्योंकि हर जगह वो करनी पड़ती है. अब आप सोचोगे कि मैं तो मिडिल क्लास से हूँ, लोअर मिडिल क्लास हूँ, ये है क्या करूँगा, ये थोड़ा बड़ी बड़ी बातें करते हैं, तो वो सारे हम मिडिल क्लास लोअर मिडिल क्लास से ही आए हैं. ठीक है, वो दिमाग से निकाल दो. सबसे पहले तो वो चीज़ को ख़त्म करो. दूसरी आ गई हम इंटेलिजेंस है या नहीं है. इंटेलिजेंस मेरे को नहीं पता कोई है भी चीज़ या नहीं. इंटेलिजेंट कुड बी ए मिथ. एक्चुअल चीज़ होती है हार्ड वर्क. पुट ऑन हार्ड वर्क. एक्चुअल अच्छे से काम करो, एक्सपेरिमेंट्स करो अपनी लैब में जो होते हैं, थ्योरी अच्छी तरह से पढ़ो और पॉजिटिव माइंड रखो. जैसे कोई नेगेटिव बंदा बैठता उठ के चले जाओ वहाँ से, कोई फायदा नहीं है. ठीक है, क्लियर है? कोई अब तुम्हारी कोई मिडिल क्लास लोअर मिडिल क्लास नहीं आने वाली, लड़के लड़की का डिफरेंस नहीं आने वाला, क्योंकि दोनों के दिमाग अच्छे हैं, एक जैसे हैं, वे कोई फर्क ही नहीं है लड़के लड़की में. ठीक है, कोई डिफरेंस नहीं है. ठीक है, मैं एक सीधी सी कहानी, क्योंकि ये क्लियर करनी पड़ती बच्चों को. सबसे पहले लड़के लड़की का डिफरेंस सिर्फ उनके हस्बैंड और उनकी वाइफ तक की है. सोच के देखो, बाकियों को किसी को क्या लेना देना. हस्बैंड और वाइफ तक ही रहता है लड़के लड़की का डिफरेंस. बाकी किसी दुनिया में किसी इंसान को कुछ लेना देना नहीं है, और किसी को क्या लेना देना. ठीक है, क्लियर है ना? लड़कियों का भी क्लियर है ना? तो लड़कियों को भी स्ट्रगल करनी है. ओके, ये करना पड़ता है हमारी. ओके, उसके बाद जब प्लैनेट्स बन गए, हाउ दिस प्लैनेट स्टार्टेड इवॉल्विंग. नाउ फॉर एवरी प्लैनेट देयर इज अ डिफरेंट स्टोरी हाउ इट इवॉल्व. शुरू में प्लैनेट्स जब बने तो प्लैनेटेसिमस के टक्कर करने से बने, and the heat was generated. Heat was so much that it melted the entire bodies. सारे के सारे planets पिघल गए. अब पिघलने से क्या होता है, जो लोहा होता है, iron, the molten iron, it has got high density. It started moving towards the center, and it started forming an iron core. That is the reason why we have iron core in all the inner planets. Whether you have Mercury, Venus, Earth, Mars, you have iron cores. That is how it was generated. Now there is another thing which you have to appreciate, when you have computers with you, we can actually do simulation of these processes. The physical and the chemical processes that we are familiar with, we can actually simulate them on computer. We were not there when these processes were happening in nature. But using the mathematics, we can simulate them on the computer. That is the power of computer. ये दिमाग में रखो, कभी आपके use आएगी चीज. Use computer for doing computation, writing programs. Develop a culture of writing programs. It will be very useful to you. कभी नुकसान नहीं होगा. Future में बड़ा use. What about moon? Now, Apollo astronauts, they brought the lunar samples. Those lunar samples were analyzed. The composition of the moon is almost similar to that of Earth. So the proposed hypothesis is that there was a planet in the early solar system by the name Dia. This Dia hit the Earth. It was a very powerful impact. The debris were thrown in the space. These debris accreted. It resulted in the formation of moon. 100,000 साल के अंदर मून बन गया. बड़ी इंटरेस्टिंग कहानी है. एक आके बड़ा जोर से प्लैनेट टकराता है, मलबा बाहर निकलता है, ओके, वो मलबा इकट्ठा हो जाता है, वो मून बन जाता है. That explains why the composition of moon is just like that of Earth. So the moon was formed out of Earth. Okay. Now, this is one particular branch of subject, atmospheric sciences, where we have very limited people working, especially in the upper region of country. We have very limited people working in atmospheric sciences and climatic studies. This is a very rich subject by itself. What is atmosphere? It's a blanket of gas that is surrounding us. When we study atmospheric sciences, we want to understand how the atmospheres of different planets evolved. Mercury का कैसे करा? Mercury का है नहीं, बहुत कम है. Venus का, it's a CO2 rich. Very harsh environment है Venus पे, both high temperatures are because of high carbon dioxide. Then how the Earth atmosphere evolved, how the Venus, Mars, ऐसे ऐसे करते we go towards the outer solar system. Okay, now, this is what we have, we understand as far as the evolution of our atmosphere is concerned. बहुत ज़्यादा वैज्ञानिकों ने बहुत सारा डाटा इकट्ठा करा, अर्थ से रिलेटेड, एटमॉस्फेयर से रिलेटेड, मॉडलिंग करी, वो करा, ये उसका निचोड़ है. This is what we understand. Right now we are somewhere here. Now, this is the present abundance. Oxygen is 21%, nitrogen is 78%. That is what you know as far as our atmosphere is concerned. But if you go back in the history, 4.5 अरब साल पहले क्या था? 4.5 अरब साल पहले our planet Earth was formed. It was having an environment which was actually rich in ammonia, methane, hydrogen. जो accretion disk की gases थे थोड़ी बहुत वो थी. अब क्या हुआ? I told you that when the Earth was formed, it was in the molten state. Because it is in the molten state, जिस जगह पे भी पानी था Earth के अंदर, भाप की तरह से, it came up. It erupted out by volcanoes. There were thousands of volcanoes going on in the early Earth. So all the water vapors came out. Along with it, carbon dioxide came out. So the entire planet degassed. Degassed means whatever water vapor it was having internally, carbon dioxide, it came down. It came to the surface, to the atmosphere. So you see an increase in the water vapor. अब जब आपका वाटर वेपर इंक्रीज कर जाए एटमॉस्फेयर में, फिर क्या होता है? You have rains. So for thousands of years there were rains everywhere. मूसलाधार बारिशें होती रही हमारे ग्रह के ऊपर, कितने सालों तक चलती रही, हजारों सैकड़ों सालों तक चलती रही. Because of which all the water bodies were generated. The water bodies like seas, oceans, ponds, सब कुछ generate हो गया. Now the interesting thing comes. Somewhere here, 4 अरब साल पहले, आज से, when you have the appearance of these water bodies, some reactions started, chemical reactions, which involves the catenation property of carbon. So carbon will form certain amino acids, which are the building blocks of proteins. And protein is what makes every structure in whether any species you consider. It's protein. So some basic amino acids were formed, and then you have the first appearance of a single cell. So then the single started evolving. Initially, since the atmosphere was rich in carbon dioxide, so these cells used to take carbon dioxide, leke, water leke, they used to produce glucose and the derivatives of that, and oxygen. These species are what we refer to as cyanobacteria. They appeared everywhere wherever there was a water. This is the origin of life, the life which is going to consume carbon dioxide. Now something interesting happened. This carbon dioxide, initially it was going up, then it started declining. Because carbon dioxide has a tendency to react with water and some other elements, and that is how you produce carbonate rocks. तो आपके जो carbonate rocks deposits होने लग गए हर जगह पे planet के ऊपर. So it trapped carbon dioxide that way. So it started going down. Now because of the fact that these cyanobacteria are generating oxygen, the oxygen abundance started going up in the atmosphere. This oxygen O2 is not a primary molecule in our atmosphere. This is actually a secondary. It has been synthesized by cyanobacteria and their cousins. One of the cousins eventually evolved into what we refer to as chloroplast, which you see in plants. That is how the photosynthesis works. So you have a complete picture. We do not say that this is the ultimate picture, but this is what the thing is. We are fortunate enough that we are living in an era when we actually have at least a glimpse of what has been going on. Think yourself very fortunate. Especially the science students are very fortunate people. You don't need anything else except for a final job that is needed, okay? So the oxygen level started going up, the CO2 level started going down. Somewhere here a remarkable thing happened. The ultraviolet photons from the sun, they strike the atmosphere, they started creating ozone. Okay, so there is a chemistry that goes on there. Ozone layer is created, so majority of the ultraviolet photons are stopped ozone layer se. Ab jab ultraviolet niche nahi aayegi, so what will happen is that the life which was initially confined to the water bodies, they started moving to the land. वो जमीन पे आने लग गए. Amphibians, reptiles, mammals eventually evolve हो गए. आज की डेट में आप जो भी लाइफ देख रहे हो, बड़े बड़े जो स्पीशीज देख रहे हो, that has come only in the recent time. इतने से स्केल में ही आए हैं. Just imagine that. Okay, so then there is a detailed story. Then the oxygen started going up till we reach this point, a point of criticality. Point of criticality, I will explain what is the point of criticality. Because what we did was that in the last 200 years, we started burning lot of fossil fuels. कोला ज़्यादा जला दिया, पेट्रोलियम प्रोडक्ट्स जला दिए, उसने क्या करा CO2 को बढ़ा दिया. अब याद रखो CO2 ने ऑक्सीजन बनाई, आप अब CO2 बढ़ाते जा रहे हो. So you have created a mess. So CO2 content has gone up. The temperature of the earth has gone up drastically. It is 1 degree centigrade everywhere. Okay? This is what you refer to as global warming. अगर इसको आपको कोई नहीं मानता, बड़े लोग नहीं मानते हैं इसको, एक बड़ी छोटी सी चीज करो, गूगल अर्थ पे जाओ, गूगल अर्थ पे जाके एनिमेशन रन करो, हिमालयस की, जिधर ग्लेशियर्स दिखते हैं, उधर हिमालयस की एनिमेशन रन करो फ्रॉम 1980 ऑनवर्ड्स. 1980 से आगे डाटा अवेलेबल है इमेजेस में. You will see that the glaciers have started receding. Glaciers shrink कर रहे हैं, the rainfall is increasing, the snowfall is declining. We have created a mess. For whom we have created this mess? For us. The rest of the universe does not matter. For the rest of the earth it does not matter. Of course some species will disappear, new species will appear. There are almost like a trillion of species on earth. कोई इधर कम होगा, उधर ज़्यादा होगा, किसी को कुछ नहीं परवाह है, कोई नहीं फर्क पड़ेगा. Universe works without any mind. Universe does not have any mind. These things are purely technical. Some of you who have technical know-how, they are inclined towards technical things, they can pursue this. So the idea here is that you have to, if you need communication, you need a satellite. If you need remote sensing, you need a satellite. If you want to watch how the enemy country is working on the rivers which are entering into your land, you need a watch from the sky, okay? So you need basically remote sensing satellites. How does the remote sensing satellites or any satellite for that matter works? Simple telescope से हम ऊपर देखते हैं. With a satellite or a spacecraft or any entity which you put in the space, you do downward. Simple example is Google Map, or Google Earth. That is a classic example. GPS. GPS using satellite, a constellation of satellites. That gives you the precise location. If you want to go to some particular place, you feed it in the GPS system. It guides you to that place. That is technology. It's really a mind-boggling technology when you start understanding how it works, what is the physics it conveys, and what is the mathematics that it works with. It's a remarkable thing. एक काम करो, एक छोटा सा जो टेक्नोलॉजिकल इश्यू से, टेक दिस एज ए होमवर्क. आपके पास सबके पास स्मार्टफोन है. अपने स्मार्टफोन्स के देखो कितने सेंसर्स लगे हुए हैं. जिनका तो एंड्रॉयड फोन्स हैं, वो एक एंड्रो सेंसर करके डाउनलोड कर ले ऐप, वो आपको सारे सेंसर्स दिखा देगा. आपको फिर उसके देख के समझ आएगी कि आप इसको स्मार्टफोन कहते क्यों हो. स्मार्टफोन इसलिए नहीं कहते कि आप फेसबुक करो या व्हाट्सअप करते रहो सारा दिन बैठ के. स्मार्टफोन मतलब वो रियल में स्मार्ट है. ट्राई टू अंडरस्टैंड द सेंसर्स. वैसे ही करो इसको. इस उम्र में सब चीजें अच्छी लगती हैं इस टाइप की. तो एक एंड्रो सेंसर है, जो और भी कई है सेंसर्स, बेनतहा है कोई, बट डू दैट थिंग. अपने मोबाइल फोन को समझो अच्छी तरह से, स्मार्टफोन को. ओके, दिस इज द इमेज ऑफ अर्थ एट द नाइट टाइम. यू कैन आइडेंटिफाई द वेरियस सिटीज. एक इंटरेस्टिंग इसमें चीज है, वो आप करके देखना कभी एक्सरसाइज. ये जो इंडिया पाकिस्तान का बॉर्डर है, व्हाट दे हैव डन इज दे हैव पुट सोडियम वेपर लैंप अक्रॉस द एंटायर बॉर्डर. एक तो फेंसिंग कर दी हुई है, ऑन टॉप ऑफ इट दे हैव पुट अ सोडियम वेपर लैंप इक्वल डिस्टेंस पे. सैटेलाइट इमेज वो दिख जाता है. अगर आप हाई रेजोल्यूशन में जाओ सैटेलाइट इमेजेस में, आपको वो पूरा बॉर्डर दिखता है रात को, एकदम नाइस बॉर्डर. फिर आप नाइल डेल्टा के ऊपर जाओ, वो बड़ी अच्छी दिखती है नाइल डेल्टा. जो और डेल्टा, इंडो गैंजेटिक डेल्टा दिखेगा अच्छा. यू कैन आइडेंटिफाई द सिटीज. दिस इज जस्ट वन ग्लिम्प्स ऑफ व्हाट द रिमोट सेंसिंग इज ऑल अबाउट. अब इसको हम और कॉम्प्लेक्स करते सकते हैं. मिनरल रिसोर्सेज, फिशरी या और चीजें, वाटर रेजर्वायर्स. there are endless uses of remote sensing. We do remote sensing of Earth. Now we do remote sensing of other planets. जो Chandrayaan mission, Mangalyaan mission, they do remote sensing of those objects. एक मैंने चीज बोली थी और मॉर्निंग टाइम से people are telling that thing. आज की डेट में हम सारी इंफॉर्मेशन निकालना चाहते हैं. This is sun in the visible region. This is sun in the radio wave, infrared, X-ray, UV. You name any electromagnetic part of the spectra, you will have that information. That is the state of our technology. You need, of course, different telescopes and different detectors. Why do we do that thing? Because we want to get the entire physics information about that object. Whatever is communicated over there, information, it's different here. हर जगह different है. The physics works differently in different energy regimes. कुछ एनर्जी रिजीम में एक तरह से करती है, कुछ में किसी तरह से करती है एक ही चीज. You have a single fellow, sun in this case, but you observe it in different wavelengths. Okay. How many satellites and spacecrafts do we have? There is a very big number. It goes in thousands. That is a remarkable thing. That is what human beings have achieved. And it's a positive achievement, not to be considered in a very, through a narrow-minded approach. This is just a list of very small things. बीच में तो एक मैसेंजर का अभी एक पोएम सुनाई थी, जो एंकर है उन्होंने अभी पोएम हिंदी की सुनाई थी मैसेंजर मिशन को लेके और चंद्रयान को लेके. This messenger mission actually went to Mercury. You have a New Horizon mission that went to Pluto. You see this thing? So if you think about just these 6 countries, 6 major European space agencies, NASA, ESA, Japanese, Chinese, Indian, and now you have other. Just think about it. There is literally not a single place in our solar system where they have not sent or they are not planning to send a spacecraft. जब आप लोग सोचो जरा, आप जब बड़े होने लग जाओगे, अभी तो आप छोटे हो, जब बड़े होने लग जाओगे, you think that what would be the state of affair? Okay, the way the things goes on in our country, progress आ रही है, prosperity आ रही है, सब कुछ अच्छा हो रहा है, तो आप लोग 90 तक जाओगे, उसके ऊपर भी जाओगे. So start planning your life. हाँ, ऐसे नहीं निकालनी, कुछ करो, ठीक है? जितना भी कर सकते हो आप करो. आज जितना भी आपके पास जोर लगा दो, कर दो, कुछ कर दो, ठीक है? ओके, अब इन सब से हम कंट्रोल कैसे करते हैं? We have this dish antennas. There is a network of dish antennas throughout the planet. This is how we actually get information from the spacecrafts and the satellites, and this is how we send information. Working on a spacecraft is almost like playing with a remote control car. If you are fed up of playing with a remote control car from your childhood, this is where you actually can now do the things. अभी तक आपके सिर्फ parents पैसा खर्च रहे थे remote control cars पे. Now the government of India will spend it. Okay, you have to do science. Instruments, equipment, laboratory equipment. These are actually toys, and not to be taken like they तोड़ने वाले नहीं toys. So serious, okay. चलो. जो एक्सपेरिमेंट करते हो उसको सीरियसली करा करो, ये दिमाग में रखो. इफ यू कॉम्प्रोमाइज विद द एक्सपेरिमेंटल थिंग्स दैट यू आर सपोज्ड टू डू एट हियर, द एंटायर नेशन गेट्स कॉम्प्रोमाइज समवेयर. ओके, तो वो ध्यान रखो. व्हाट डू वी डू? ये सारा का सारा जो स्पेसक्राफ्ट है, दिस इज चंद्रयान. यू माउंट इट हियर एट द टिप ऑफ द रॉकेट, इसको हम कहते हैं पेलोड. देन द रॉकेट लिफ्ट्स ऑफ. और रॉकेट किस प्रिंसिपल पे बेस्ड है? It's a very simple physics principle, conservation of linear momentum. But the unfortunate part is, अगर आपको रॉकेट को इधर भेजना है, आपको कुछ उधर फेंकना है. आप उधर फेंकोगे तो वो इधर जाएगा. अब एक करकरा के एक मैथमेटिक्स की इक्वेशन आती है, उसको हम कहते हैं रॉकेट इक्वेशन. वो उसमें डिफरेंशियल कैलकुलस कुछ थोड़ी सी आती है, माइनर सी. आपने गैस इधर फेंकोगे तो रॉकेट इधर जाएगा. अब अपना दिवाली का रॉकेट याद करो, गैस निकलती है इधर, हॉट गैसेस, उसका जो मोमेंटम है वो उधर जाएगा mu, और रॉकेट आपका उसका मास m है, ये इधर आएगा. अनफॉर्चुनेट चीज ये है कि आपको बहुत ज्यादा गैस इधर फेंकनी पड़ती है, तो आपको बहुत ज्यादा ईंधन लेकर जाना पड़ेगा रॉकेट के अंदर. आपको एक तो ईंधन लेके चलोगे, द फ्यूल, एंड यू हैव टू यूज ऑक्सीडाइजिंग एजेंट, क्योंकि ऊपर तो ऑक्सीजन है नहीं, और आपकी कोई फ्यूल चलाना है आपको, उसको इग्नाइट करना है तो ऑक्सीजन चाहिए आपको. तो दे पुट ए टैंक विद द फ्यूल, दे पुट ए ऑक्सीजन. अब ये लिक्विड हो सकता है, गैस हो सकता है, सॉलिड हो सकता है. लिक्विड सॉलिड तो प्रेफर करो, क्योंकि गैस लेके जाओगे तो बड़ा सारा टैंक लेके जाएगा, वो और झमेला है. वो मास डिस्ट्रीब्यूशन खराब होगा, रॉकेट घूमता रहेगा, वॉबलिंग करेगा, कॉम्प्लेक्सिटी है सारी. लेकिन प्रॉब्लम यह है कि आपका 80-90% तो ये इन चीजों पे लग जाएगा, ये फ्यूल को लेकर जाने में और इसी में. ये एक्चुअल में बहुत बड़ी प्रॉब्लम है, और इसका कोई तोड़ है नहीं. कुछ भी कर लो, आपको कुछ ना कुछ करना पड़ेगा. लोग कुछ टेक्नोलॉजी ट्राई कर रहे हैं कि आप कैटापुल्ट कर दो किसी तरह से ऊपर, फिर ऊपर से पकड़ लेगा. आप लोग देखते होगे यूट्यूब देखते रहा करो, स्पेसएक्स की फ्लाइट्स देखो, वो सब कुछ देखो. इट्स एन इंटरेस्टिंग थिंग. It makes your mind creative actually. Okay, so this is how the rocket works. This is what our state of affair is as far as our country is concerned. This is our what they call as our main workhorse, PSLV. Maximum launches इसी से करी गई हैं. PSLV की 4 stages होती हैं. पहली stage पहले चलेगी जो maximum thrust देगी. And then when the rocket goes up, जो भी इसका ईंधन और ऑक्सीडाइजिंग एजेंट यूज कर लिया आपने, अब उसको थोड़ी लेकर, अब खाली तीनों को थोड़ी लेकर जाओगे ऊपर, उनको फेंक दोगे. ठीक है, अगर आप रिवाइव कर सकते हो तो रिवाइव कर लो, अदरवाइज इट्स गॉन. देन द सेकंड स्टेज बर्न्स, इट विल बर्न फॉर सम टाइम, देन इट इज थ्रोन आउट. थर्ड स्टेज बर्न्स, फोर्थ स्टेज. ये सब कुछ इसलिए हो रहा है क्योंकि आपके पास एक बेसिक प्रॉब्लम है, क्योंकि आपको बहुत कुछ पीछे फेंकना पड़ेगा ताकि आगे धकेला जाए रॉकेट आपका. और गैसेस फेंकनी पड़ेगी पीछे, कुछ फेंकोगे तभी इधर आओगे, ठीक है। इसके बाद आता है GSLV टाइप ऑफ रॉकेट्स, जो बेसिकली चंद्रयान के केस में यूज करा था, उसका डेरिवेटिव यूज करा गया था। दिस फेलो यूजेस क्रायोजेनिक इंजन। क्रायोजेनिक इंजन में क्या है, आप हाइड्रोजन लेते हो, ऑक्सीजन लेते हो, उनको बर्न करते हो, हाइड्रोजन को ऑक्सीजन में, इट प्रोड्यूसेस वाटर एंड दिस रिएक्शन इज एक्सोथर्मिक, सो you get hot fumes of water vapors. So that is the final stage of this rocket. This is something which is required if you want to launch very big satellites or spacecrafts. INSAT series खासकर, बचपन में मेरे को याद है INSAT सीरीज एक जब 1B जारी थी तो उन्होंने कहा कि फ्रेंच गुआना से लॉन्च करेंगे, हम नहीं कर सकते। मैं शायद 9th में था, पता नहीं उस टाइम, मेरे को भी थोड़ा सा ऑकवर्ड लगा कि ये क्या प्रॉब्लम है। लेकिन जैसे जैसे हम बड़े होते गए, इसरो एक्चुअली एक्सपेंडेड ट्रिमेंडसली। आप इसरो क्या कर सकती, क्या नहीं कर सकती, जब आप पूरा डिटेल्स में जाओगे टेक्नोलॉजिकल, तब जाके आप एप्रिशिएट कर सकोगे। एक साधारण आदमी के लिए एप्रिसिएशन अभी पॉसिबल नहीं हो सकती, जब वो डिटेल्स में जाएगा तब उसको जाके वो एक्चुअल रियल सेंस में एप्रिशिएट करेगा। जस्ट सोचो जरा, इतना बड़ा रॉकेट जा रहा है ऊपर और उधर फेंक रहे हैं मून के ऊपर। अच्छा सोच लो, मून ने उसको पकड़ा ही ना, मून की ग्रेविटी ने उसको पकड़ी नहीं, फिर क्या करोगे? वो तो गया स्पेस के अंदर। वेरी कॉम्प्लेक्स थिंग। दे यूज मैथमेटिशियंस हु डू द डायनामिक्स, then they use literally every sort of engineers who devise everything, computer, mechanical, sab kuch karke, then it works. This is the recent thing which happened last week, I think. Ye hai small satellite launch vehicle. ISRO, as I understand, ISRO what it is doing is that it is trying to outsource. अब एक और इंटरेस्टिंग चीज होगी, जब आप लोग जब तक बड़े हो रहे होगे ना, कुछ प्राइवेट कंपनीज अपने रॉकेट बना के भेजने लग जाएगी, इसरो उनको टेक्नोलॉजी दे देगी। हो सकता है आप लोग कोई उस कंपनीज में काम कर रहे होगे उस टाइम पे, तो आप अपॉर्चुनिटीज ले सोच के चलो, ठीक है। मतलब आप सिर्फ इसरो को मत फोकस करो, जैसे एक पिछला क्वेश्चन भी किसी ने पूछा था, प्राइवेट कंपनीज ही करने लग जाएंगी, और थ्योरेटिकल काम भी आप काफी कुछ कर सकते हो, और भी चीजें कर सकते हो। तो थोड़ा पॉजिटिव रहो और मान के चलो कि आप करने के कैपेबल हो, नेगेटिव थॉट्स ना लाया करो। ओके, ये इसकी एनाटॉमी है। पता नहीं कहां से मेरे को फिगर मिल गई, लेकिन जबरदस्त चीज है, मेरे को नहीं पता, कोई इसरो का ऑब्जेक्ट करेगा बंदा, मे बी समबडी विल ऑब्जेक्ट। ओके, आई यूज इट एक्सटेंसिवली। सो यू हैव डिफरेंट फ्यूज, मैं इसकी पूरी डिटेल समझा सकता हूं क्या क्या थ्रस्ट बना रहा है, लेकिन एक चीज है, इतनी ज्यादा इसमें टेक्नोलॉजी है, इतनी ज्यादा साइंस है, एक टेक्नोलॉजिस्ट लगा रहेगा एक्सप्लेन करने, लेकिन वो एक बंदा वो जो आपका कर रहा है ना एंकर, ये एक छोटी सी पोएम बना के ज्यादा इफेक्टिवली समझा सकता है। ए पोएट कैन एक्सप्लेन दिस थिंग इन अ बेटर मैनर, जो आर्टिस्ट जो ड्राइंग करता है। इट्स अ रिमार्केबल थिंग कि हम कर सक रहे हैं ये चीजें। इससे ये पता लगता है कि जो हम सोच सकते हैं हम कर सकते हैं, कैपेबिलिटी है। मैं थोड़ा पॉजिटिव ही करता रहता हूँ स्टूडेंट्स को, मेरा काम ही है, नौकरी मेरी वो है, स्टूडेंट्स को पॉजिटिव करते रहो, और बाकी तो पढ़ाई तो खुद भी कर लोगे, पढ़ा भी देता हूँ थोड़ा, इतना भी खराब हालत नहीं है, लेकिन स्टूडेंट्स को पॉजिटिव करना बहुत जरूरी है। अब पता नहीं क्यों डिमोरलाइज, हमारे छोटे छोटे आईडी करंट सोसाइटी में घूमते रहते हैं, वो डिमोरलाइज करते रहते हैं। वो एक आ गया आईडी करंट तुम्हारे को डिमोरलाइज कर गया, पता नहीं क्यों कर गया, भाई पूछ तो लो उससे क्यों करके गया। थोड़ा सा अपना इंट्रोवर्ट भी बन लो, पॉजिटिव रहो, थोड़ा सा एक्सट्रोवर्ट की बनने की ज्यादा जरूरत नहीं, फिर सारे गप्पे मारते रहोगे सारे टाइम, गप्पे ना मारो। दिस इज क्रायोजेनिक इंजन, ये स्टैंडर्ड डायग्राम है। हाइड्रोजन एक गैस, लिक्विड हाइड्रोजन कर लो, गैस करोगे तो बड़ा फिर लेके जाओगे कंटेनर, लिक्विफाई करो, इसको लिक्विफाई करो। अब इनको लिक्विफाई करने के लिए आपको 200 डिग्री से भी नीचे लेके जाना पड़ता है टेम्परेचर, वो आपको करना पड़ेगा क्रायोजेनिक से। क्रायोजेनिक इज द फिजिक्स ऑफ लो टेम्परेचर। आप इसको लिक्विफाई करके रखोगे गैस को, तभी कॉम्प्लेक्सिटी आती है। फिर आपको इसको इंजन के अंदर लेके जाओगे, इधर बर्न करेगा इंजन के अंदर, फिर इसकी इंजन की थ्रॉटल की नोजल की डिजाइन इस तरह से होती है, ये बर्नौलीज प्रिंसिपल से उसको एग्जॉस्ट होता है, उसको बूस्ट अप कर देता है वेलोसिटी को। तो आपका जो मोमेंटम है वो बहुत ज़्यादा हो जाएगा, जो बैकवर्ड मोमेंटम है और थ्रस्ट आपको बहुत अच्छी मिलेगी। दिस इज क्रायोजेनिक इंजन, ओके। वो GSLV की एनाटॉमी है, वो तो मिल जाती है स्टैंडर्ड, वो PSLV की पता नहीं कहाँ से मिली थी, वो हिट कर गए। दिस इज समथिंग विच हैज बीन डिस्कस्ड इन द मॉर्निंग, आई विल नॉट गो इन फर्दर डिटेल। ये चंद्रयान मिशन था, ये प्रॉपरली लैंड कर गया। एक वैज्ञानिक था, जर्मन वैज्ञानिक, उसका नाम था हॉफमैन। हॉफमैन ने कहा कि आप इधर से मून को भेजना, आप सीधा ना भेजो, उसको मैं पैराफ्रेज कर रहा हूं, उसने कुछ और बोला। उसने कहा कि आप पहले इसको एक्सेलरेट करके ऐसे ले जाओ अर्थ के आसपास, एक बार इधर रॉकेट को फिर से बर्न करो, फिर वो इधर जाएगा, ऐसे ऐसे बढ़ाते रहो। तो आप जैसे एक गुलेल होती है ना, शायद आपको कुछ लोगों को पता हो, गुलेल होती है, आप उसमें रखो, ऐसे करके करो, फिर ऐसे करो, मतलब आप थोड़ी देर के लिए बूस्ट अप करते हो और फिर छोड़ दो। गुलेल ऐसे ही चलाते हैं। अब तो नहीं आपको पता होगा, मॉडर्न जनरेशन हो। अब वो गुलेल से जो जाएगा, अब ये मून ने उसको कैच करना है, आपने उस डायरेक्शन में डालना है कि जब ये इधर जाएगा मून उधर हो। ये नहीं है कि मून आज इधर था तो आपने इधर फेंका, मून उधर जा चुका हुआ है। इट्स अ वेरी कॉम्प्लेक्स थिंग। आई टेल यू वन थिंग, even sometimes when I go into the details of what these people actually do, I have goosebumps. मतलब रोंगटे खड़े हो जाते हैं, क्या करते क्या है चीज। और ये अभी ये इसरो कर रहा है, जो हमारे कंट्री कर रहे हैं, रिस्पेक्ट टू ऑल द अदर नेशंस। जो नासा करता है वो पागलपन है। नासा इज दे आर मैड। वो जो एस्ट्रॉइड्स के ऊपर मिशन भेजते हैं, हम कई बार टेक्निकल, वी गिव टेक्निकल डिटेल्स, रिसर्च बेस्ड जो होती है, the type of missions they send actually is remarkable. They use gravity assists of planets. जुपिटर को यूज कर लेते हैं कि बूस्ट हो जाए आपका स्पेसक्राफ्ट और तेजी से बाहर जाए। दैट इज रिमार्केबल। अगर आप इस प्लेनेट पे रहते हो और आपको ये नहीं पता, मेरे को नहीं लगता फिर आपको बहुत अच्छी स्टेट ऑफ अफेयर है। तो आपको पता होना चाहिए कहाँ क्या 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 हो रहा है। आई विल स्टॉप हियर।
Thank you, sir. Please maintain the silence. Please maintain the silence. Thank you, sir, for such a very, very, very interesting talk. Now, moving forward with the program, it is time for an interaction session with our speaker. And we have got some questions shortlisted from the students. Actually, all the questions were very interesting, but we cannot ask all the questions. So we have shortlisted some 10 questions. So we'll now put forth these questions to Professor Sahijpal on the behalf of those students.
So if I'm able to answer the question, I will answer. Otherwise, I'll put it on my seniors. Okay, they will answer it. Okay, so okay, so it's very convenient for me. Okay, please ask.
So hello everyone. The first question that we have is from Pundarik from KV IIT. Do our scientists have any theoretical plans for reaching long distances, as space missions are done to find life too, and we haven't found any in our solar system yet? And to find that, we are not only one in existence, we have to find planets which are many light years away from us.
Okay, इसके मैं I will give this answer in a very fragmental manner. First of all, there is nothing special about Earth that we should have life only on Earth. The only reason why we have life on Earth, we have liquid water, we have carbon, nitrogen, oxygen in a particular conducive environment, comfortable magnetic field, 0.5 Gauss, we are living happily. Whether we are not here as a Homo sapien, it is immaterial. Whatever life exists, it is life. Technical definition of life is something which can reproduce itself. Okay, that is the technical scientific definition of life. आप किसी मशीन को लाइफ नहीं कह सकते, ये वो कहते हैं, लेकिन मेरे को मशीनों में भी लाइफ दिखती है, वो अपनी परसेप्शन है, लेकिन वो मेरा नहीं बॉदर करते, वो रिप्रोडक्शन इज द थिंग. The life we know is basically water based and carbon based. Okay, there is a possibility that on Titan, which is one of the satellites of Saturn, there is a chemistry based on methane. Just like we have water lakes, water bodies, they have methane lakes. So people have already speculated that there could be a life form based on methane, methane doing the chemistry. ठीक है? They send a Huygens mission, उसने photography ली हुई, अब YouTube में जाओगे, you will see that thing. But so far no trace of life. मार्स के ऊपर वो एक मिला था बहुत साल पहले एक एविडेंस, there is a fossil life. मार्स के ऊपर नहीं, लेकिन वो contradictory हो गया. We do not have any specific evidence. So at this moment we do not have any specific evidence that there is life in our solar system. But in future they are planning that they will send some spacecrafts containing submarines, small form of that, which will dig into the satellites of Jupiter and Saturn. Jupiter और Saturn के जो satellites हैं बहुत ज़्यादा water है उनके ऊपर, oceans है बड़े बड़े, तो वो देखते हैं कि शायद उनके अंदर life हो. तो टाइटन है जहाँ सैटेलाइट्स ऑफ जुपिटर, सैटर्न, यूरेनस, इनके ऊपर पॉसिबिलिटी है. बहुत दूर बाहर भेजना, वो दैट इज रूल्ड आउट. एक हम बड़े बचपन की हमारी एक फैंटेसी होती थी एस्ट्रोनॉट बनेंगे. कई तो सीधे आगे मेरे को पूछ भी लेते हैं एस्ट्रोनॉट बनेंगे. फिर उनको बताओ कि ये 10G फोर्सेस एक्सपीरियंस करते हैं, वो तो हम तो एक झूले में बैठ के घूम जाते हैं. वी आर नॉट कैपेबल ऑफ बिकमिंग एस्ट्रोनॉट्स. अदर रीजन इज अगर आप मार्स तक भी भेज रहे हो ह्यूमन बींग्स को, वो भी there are chances that that fellow will develop cancer unless until you fight against cancer. Solar radiation ही बहुत ज़्यादा है. और उसके बाद तो बड़ा मुश्किल है, उसको डिप्रेशन हो जाएगा, 100 तरह की प्रॉब्लम हो जाएगी. ग्रेविटी कम है उस जगह पे के स्पेसक्राफ्ट के अंदर, तो मसल नहीं रहेगी. मसल की क्या जरूरत है, ग्रेविटी नहीं. मसल कहेगी मेरी क्या जरूरत तेरे को, तो ग्रेविटी नहीं है. स्केलेटन कहेगी तेरे को क्या मेरी जरूरत है. तो वो बड़ी ज़्यादा कॉम्प्लिकेटेड प्रॉब्लम है. अल्टीमेटली कर करा के अब ये कहानी बनती है कि आप खुद ना जाओ कहीं पे ढूंढने के लिए, आप अपने आर्टिफिशियल इंटेलिजेंस बेस्ड रॉबोट भेज दो, वो कर लेंगे. तो आपकी जो एक नोशन है ना स्टार ट्रैक जैसी, अगर किसी ने देखी है कि वो स्पेसक्राफ्ट जाती जा रही है, आगे जाई जा रही है और ढूंढते जा रहे हैं, वो नहीं होने वाली. हम इधर ही रह रहे हैं, हमने नहीं कहीं जाना. अब मैं डिप्रेसिंग लग रहा होगा, लेकिन वो आप अगर रॉबोट भेज रहे हो और वो इन्फॉर्मेशन आपको भेज रहे हो, आप क्यों जा रहे हो, क्यों लाइफ खराब कर रहे हो. फिर आपको जनरेशनशिप बनानी पड़ेगी, वो भी कॉन्सेप्ट है. जनरेशनशिप मतलब एक फैमिली भेज दो उधर, मतलब वो बाप जाएगा तो माँ, उसकी वाइफ और बच्चे भी जाए ना, फिर वो उनकी आगे ऑफस्प्रिंग वहीं होगी, तो वो ऐसे ही चलता रहेगा. वो जाएगी, वो भी, लेकिन वो क्या पता नहीं. इट्स नॉट गोइंग टू वर्क. द ओनली थिंग इज दैट रिस्पेक्ट द लाइफ विच इज स्टैंडिंग इन फ्रंट ऑफ यू. वो उधर ढूंढते रहोगे, फिर कहोगे यहाँ नहीं, यहाँ पे लड़ते रहते हो आपस में एक दूसरे से, वो उधर मिलने से क्या होगा. तो मेरी ये परसेप्शन है, ना को फालतू के उधर ना ज़्यादा एफर्ट करो. मेक दिस प्लैनेट वर्थ लिविंग फॉर एवरीबॉडी. क्या कुछ नहीं मिलने वाला. हाँ मैं जल्दी करता हूँ, जल्दी कर.
This question was asked by Pundarik from KV. Can he stand up, please? Okay, can we have a huge round of applause for Pundarik? The next question that we have is from Siddhi Shri from KV, 11th class. Can you please stand up? Okay, so she has asked, how to manage the waste generated in the space? How do we manage the waste generated in the space?
वेस्ट हम इंडिया में वेस्ट नहीं जनरेट करते. मैं सच में सीरियसली कहूँ, आप जाओ किसी, मैं कंट्री का नाम नहीं लूँगा, जो एडवांस कंट्रीज हैं, वो एक हफ्ते के अंदर, मैं खुद रह कर आया हूँ, एक हफ्ते के अंदर इतना ज़्यादा वेस्ट जनरेट कर देते हैं. प्लास्टिक की बॉटल्स, फ्लू कितना कुछ चीज़ें हम नहीं करते. हमारा कूड़ा जो होता है, वेस्ट की बात है ना, कूड़ा ही हो गया. पंजाबी तो नहीं बोल दी ना. ओके, बेसिकली द गार्बेज. You have basically two type of garbages. One is totally organic. If you have organic garbage, just put, if you have a kitchen garden, put it there, dump it there. A pit वो बना देते हैं, you do that thing. If you have plastic thing, reduce it. Don't create a hump of mountain outside your cities. वो भी लेकिन they are managing. As such Indians, we don't create lot of garbage. I can tell you on this, maybe some of our senior scientists will agree with this thing. वो the Westerners are capable of generating lot of garbage. Garbage हो जाएगा generate. वो बड़ी बात नहीं है. और उसके ऊपर what they did, जो चंडीगढ़ में the garbage hill station they have created, उसके ऊपर वो मिट्टी भी डाल देते हैं, तो हो सकता है वो फ्यूचर में हिल स्टेशन बन जाए. Okay, कुछ तो बन जाएगा, but they recycle it. Our garbage is more like organic. वो हम reduce कर सकते हैं, अपने kitchen garden में डालते रहो.
Sir, clarification is it's the garbage generated in space.
Garbage generated in space. मैं इतना वो हो जाता हूँ excited. Garbage generated in space, इतनी ज़्यादा वो satellites हैं. Whenever there is a collision, it generates more satellites. People have done simulations. Lot of garbage is there. Now the question is that why are they launching small satellites? They should not. Maybe this is my perception. कि जो कई छोटी-छोटी वो भी करने लगी हैं colleges, universities कि हमने एक छोटी सी satellite कर दी launch. मेरी perception ये है, I am not any spokesperson for my university or for government. It should not be done. आप गिनती के satellites रखो, उनको manage करो, वो लोग discuss करते हैं, you send something, bring it back, या कुछ कर दो, उसको dump करो. क्योंकि there would be a cascading effect eventually. Once you have so lot of garbage, वो एक garbage वो वही चीज है. अब इधर भी Indians ने ज़्यादा नहीं garbage produce करा, वो इस case में भी नहीं करा, तो दोनों हो गए.
So,
Okay.
the next question that we have is from Rehan, GIC Inter College.
अब मैं ध्यान से सुनूंगा.
Okay. So his question is, what is the key difference in the landing strategy between Chandrayaan 2 and Chandrayaan 3?
इन्होंने actually my senior colleagues will answer this thing. पिछले मिशन की ना इन्होंने psychology मेरे को लगता है जो what I read from the newspapers, they have actually changed their own mentality. In the previous mission, they were very cautious in doing this. Don't do this thing. This time they were aggressive. Aggressive is not a proper word, but it's a single word which explains everything. So they were very fixed कि land करना ही है. That is the attitude. अब वो टेक्नोलॉजी अपने आप आ जाती है जब तुम ये मान के चलो कि करना ही करना है. अभी ये ऐसे है कि तुम बिल जमा कराने गए हो कहीं पे अपना कहीं ऑफिस में, एक है कि यार करेगा नहीं करेगा, वो सोचते जाओ ये हो गया, फिर उसने कहा जा, वो चले गए, दूसरा करके ही आना है, बैठ जाओ उधर धरना दे दो. That is the attitude which they follow. Yeah, I think this is what they change their mentality actually. This is what is required actually. Technology तो आती रहती है, वो सीखते हो. एक पता नहीं एक there is something referred to as Murphy's law. वो बड़ी वो jokes हैं. I tell it to my students. अगर if some experiment is working perfectly, it means everything is wrong with that experiment. If it does not work, means you can learn something from that. So they learned things from that. फिर वो बीच वाला rocket they removed and then they did what, but the mentality, so it was more like a psychological thing. So it's a determination that you have to do it. Technology तो होती रहती है.
The next question is from Arushi Tripathi from KV, class 11th. Arushi Tripathi, class 11th from KV. Sorry, Arush Tripathi. I'm very sorry. So his question is, as we know, his question is, as we know that the solar radiation of sun is very hard, so how can Aditya L1 manage these radiations, and what are the functions of this satellite?
ये जो Aditya 1 is actually almost like Soho देख लेना एक website पे. Okay, the Soho has been there for almost 20 years. 1995 they launched and it is working even now. So you have to do proper shielding. Okay, whatever shielding is required. You have proper detectors with whatever efficiency you are having, you can optimize. So it will keep on working with that. Technically speaking, it should keep on working for a very long time. You have already taken care of radiation. It is actually staring at the radiation. But it's a dare, it's as if it is saying, I dare to see you. I dare to see the sun. So the radiation part is taken care. maybe the technical details, if please somebody wants to add, okay, किस तरह से करा उन्होंने, there are ways of handling that, you have to put something at the front side so that thing is taken care. But ज़्यादा technical detail is, I guess a lot of people will tell you. I catch things from whatever news is there or something like that. Okay, I'm not an internal man.
The next question is from Anukriti, class 10th KV. Okay. Her question is, what is the association of medical field with space missions?
Okay, the moment you have astronaut into picture, you need the entire medical sciences. Entire medical sciences mean literally everything. If you are sending a fellow to Mars, you have lot of radiation exposure, okay? Then you have to work out the management of that astronaut. Means if that fellow develops cancer, how will you monitor the cancer in the primary stages? How will you monitor, how will you manage the cancer and other radiation problems? Then the moment you are in microgravity, your muscular skeleton system is no longer required to that extent. So your muscles and bone starts losing mass, losing strength. You have to do the management for that. So that is the reason they sometimes put a gym. In International Space Station, there is a gym. There is a machine. You have to do exercise. You have to continuously monitor everything. एक एक्चुअल में एक आप YouTube में देख सकते हो कुछ ऐसे यूरोपियन स्पेस एजेंसी में they actually show you how an astronaut is trained. तो वो पूरा का पूरा you need medical sciences, complete medical sciences.
The next question is from Yuk Chauhan, class 12th KV. His question is, how are we integrating AI with space research?
AI क्या?
AI, how are we integrating it with space research?
अच्छा, जो one of the earliest lecture which I attended on AI, that fellow was actually from ISRO. I think I was in PRL at that time. That fellow actually explained what is AI. That was the first lecture I attended. So what they do is the following. They have thousands of images, remote sensing images, let us say of Earth or some other place. Okay, now how do you analyze each of this image? Okay, it's very difficult. The next thing, let us say that there is a sniper, a sniper from some enemy country. That sniper is now moving into your territory. How do you monitor that thing? So what they do is that they use AI, they train the machine to identify particular signature. For example, presence of water. For example, a shift in something. A sniper may be moving at a very slow rate. Something like maybe, see the snipers can stay at one place for 72 hours or more than that. They move so slowly. You cannot catch it. If you have put some person watching, ye aa gaya, idhar aaya, nahi aaya, kuch nahi aaya. You artificially train the computer, that fellow is continuously watching it. That will tell there is a movement integrated over this much time. So you have lots of scope in of artificial intelligence in this remote sensing, these features. Rivers के कितना change हो गया? कोई पत्थर तो नहीं फेंक दिए बड़े-बड़े, रास्ता तो नहीं change कर दिया, हमारी तो rivers ही ऊपर से आ रही हैं. वो सारा कुछ आपको देखना पड़ेगा through satellite, or there you need artificial intelligence. And further on top of it, if you are sending satellite missions to outer thing beyond our solar system, you need robots. You cannot use this human being. That is ruled out. So AI is very much relevant. Actually में अगर आप कुछ भी करना चाहते हो फ्यूचर में, AI सीख लो. कुछ भी करना है, मतलब ये नहीं मैं कर रहा हूँ स्पेस साइंस, कुछ भी करना है AI सीखो. मैं अपने लड़कों को भी कहता रहा हूँ तो मैं AI सीखो. कुछ भी करना है, मतलब वकील बनना है, वो फार्मासिस्ट बनना है, AI सीख लो भी. ये उसके बगैर गुजारा नहीं है फ्यूचर में. तो इधर तो ये है.
Okay, the next question is from Harshit Kamal, GHSS Karsa. चंद्रमा पृथ्वी का उपग्रह कैसे बना, पृथ्वी पर मानव जीवन कैसे संभव है?
हाँ, जो चंद्रमा था ना, मैंने बताया जैसे जब हमारा सोलर सिस्टम बन रहा था, पृथ्वी बन गई थी, तो एक ग्रह था, उसका नाम था दिया, वो मार्स जितना था। अब कहोगे कहानियां कैसे तुम्हारे को पता है? वो लेकिन कहानियां बनानी पड़ती है। अब ये कहानी सच्ची है? नहीं, तो और अच्छी दे दो फिर, तुम दे दो। हाँ अच्छा, वो दिया आके स्ट्राइक करा अर्थ से, अर्थ का मलबा ऊपर उछल गया और वो मलबा इकट्ठा होके 100,000 सालों के अंदर जुड़ के मून बन गया। ठीक है, इससे तो मून बन गया अर्थ का। और हमारे पृथ्वी पे लाइफ क्यों संभव है? क्योंकि हमारे पृथ्वी पे जो शुरू में डीगैसिंग हुई, वाटर आ गया और उसके बाद कार्बन हो गया। अब एक मैं आपको एक्सपेरिमेंट के रेफरेंस देता हूं, आप उसमें उसको पढ़ो। एक मिनट बच्चों, एक मिनट। एक एक्सपेरिमेंट करा गया था, यूरे एंड मिलर, याद कर लो, यूरे एंड मिलर। यूरे को नोबेल प्राइज भी मिला हुआ है ड्यूटेरियम की डिस्कवरी के लिए। हमारे वो फील्ड का दादा माना जाता है, प्लानिटरी साइंसेस का। यूरे एंड मिलर ने एक्सपेरिमेंट करा, उन्होंने एक फ्लास्क ली, उसके अंदर कुछ गैसेस डाल दी, जो मैंने गैसेस बताई थी ना, जो अर्ली सोलर सिस्टम, अर्ली सन पे, अर्थ पे थी, और उधर लाइटनिंग स्पार्क करी, उधर अमीनो एसिड्स बन गए। और जैसे ही आपके पास अमीनो एसिड्स आते हैं ना, अब पॉसिबिलिटी लाइफ की हो जाती है। तो लाइफ बन गई, सिंगल सेल बना सबसे पहले, उसमें न्यूक्लियस भी नहीं था, माइटोकॉन्ड्रिया भी नहीं। धीरे धीरे वो इवॉल्व होता गया, वो एंटर करके सिम्बियोसिस आ गया, माइटोकॉन्ड्रिया से सिम्बियोसिस, वो बन गया। फिर सिंगल सेल कहते हैं कि हम सारे काम क्यों करें अकेले अकेले, इकट्ठे मिल जाते हैं। तो वो इकट्ठे मिल गया तो मल्टी सेलुलर स्पीशीज बन गया। वो कहानी है लेकिन चल रहा है। ओके ठीक है, चला रहे हैं। ओके, तो मल्टी सेलुलर बन गए। मल्टी सेलुलर स्पीशीज माइटोकॉन्ड्रिया के साथ और न्यूक्लियस के साथ बहुत अच्छा कॉम्बिनेशन बन गया। उससे फिर एक्सप्लोजन हो गया एक तरह से लाइफ का, हर तरह की लाइफ आ गई। तो आ गए, हम भी आ गए फिर। ओके,
The next question is from Arnav Gautam, class 10th, Kendriya Vidyalaya. So his question is, why the satellites that are launched from Earth used to travel in different orbits of Earth and Moon after launching and landing respectively? And the continuation question is it possible to travel far apart last layer of galaxy?
गैलेक्सी क्या, हम अपने सोलर सिस्टम से बाहर, वो हमारा अब गया है वॉयजर। वॉयजर अब जाके क्रॉस करा सोलर सिस्टम। नहीं, बड़ा डिफिकल्ट है। हमारी जो वेलोसिटी हमारी बहुत ज़्यादा हाई नहीं हो सकती रॉकेट की, स्पेसक्राफ्ट की, एक लेवल तक रहेगी। और आप अब क्वेश्चन पूछ रहे हो कि हम सैटेलाइट्स को लॉन्च कैसे करते हैं। जो रॉकेट जाता है ना, वो अर्थ की जो इक्वेटोरियल वेलोसिटी है, अर्थ रोटेट कर रही है, वो उसको भी यूज़ करता है। तो वो क्या करते हैं, रॉकेट पहले तो सीधा ऊपर जाता है, फिर वो ऐसे बेंड होता है, वो जो अर्थ की रोटेशन है ना, वो उसमें वेलोसिटी ऐड हो जाती है, तो फिर वो अर्थ के ऑर्बिट में जाता है। अब आपके पास दो तरीके हैं मून पे भेजने के लिए। सपोज करो आपने मून पे भेजना है, इसरो नासा क्या करता है, नेशनल एरोनॉटिक्स स्पेस एडमिनिस्ट्रेशन, वो सीधा रॉकेट लिया, स्पेसक्राफ्ट में डाला, और स्पेसक्राफ्ट स्पेस में डाला, दे स्ट्रेट अवे सेंड इट टू मून। इंडिया क्या करता है, जब कोई और कंट्री ISR हो, जब ये करते हैं, ये क्या करते हैं, दे फर्स्ट ऑफ ऑल पुट इट इनटू द ऑर्बिट ऑफ अर्थ, अर्थ के ऑर्बिट में डालते हैं। जब वो एक पॉइंट पे आ जाए, जिसको हम पेरिजी कहते हैं, जो शॉर्टेस्ट डिस्टेंस फ्रॉम अर्थ है, उस पर थोड़ी देर के लिए रॉकेट को चलाते हैं, जो स्पेसक्राफ्ट के ऊपर लगा हुआ है, वो और तेजी से जाता है और उसका एलिप्टिकल ऑर्बिट और बढ़ जाता है, एलिप्टिकल ऑर्बिट, फिर वो फिर वापस आता है, फिर बढ़ जाता है। ये ऐसे है, इमेजिन करो एक मैंने स्ट्रिंग पकड़ लिया, धागा, रस्सी, उस पर पत्थर बांध दिया, तो मैं ऐसे करूंगा, ऐसे, हर बार जब मेरा हाथ ऐसे आ रहा है ना इस जगह पे, मैं उसको बूस्ट कर दूंगा, तो वो और स्पीड से जाई जा रहा है, एक जगह पे मैं ऐसे छोड़ दूंगा, वो फिर एक्सेलरेट करके जाएगा और मून उसको कैप्चर करेगा। और जो और ऑर्बिट्स होते हैं वो बहुत ही कॉम्प्लेक्स होते हैं, जैसे वॉयजर इन्होंने भेजा, वॉयजर क्या कर रहा था, वो तो बड़े अजीब तरीके से जा रहा था, ग्रेविटी असिस्ट यूज कर रहा था। एक गैलीलियो मिशन भेजा था, वो बहुत अजीब तरीके से जा रहा था, वो एस्ट्रॉयड की फोटो खींचता जा रहा था। उसने क्या करा, गैलीलियो मिशन भेजा जुपिटर पे, पहले उसने एक एस्ट्रॉयड की फोटो खींची, फिर दूसरे की खींची, फिर अपने रास्ते पे चल गया। वो तो खेलते हैं, जैसे आप लोग रिमोट कंट्रोल कार से खेलते हो, वो इससे खेलते हैं। इसको हम कहते हैं सेलेस्टियल डायनामिक्स। तो मैथमेटिशियन या फिजिसिस्ट पहले उसको वर्क करते, इक्वेशन सॉल्व करते हैं, न्यूटोनियन लॉ बेस्ड जो भी आप कर रहे हो, फिर वो ऑर्बिट्स डिफाइन करते हैं, फिर ये वो इंजीनियर्स उसको चलाते हैं उस तरह से। बहुत बड़ी टीम है, बहुत रिगरस टीम है। तो सेलेस्टियल डायनामिक्स आपको अभी जब सीनियर क्लासेस में जाओगे तब आ जाएगी। है सब कुछ आपके पास, मतलब ये नहीं है कि हम कोई फिजिक्स छुपा लेते हैं आप लोगों से, सारी फिजिक्स है, सारा कुछ है आपके पास, वो उसी से चला खेलते हैं।
So this is the last question, but there's no name on it. So if it's your question, please stand on your seat. Is it possible with technology that the light transferred from our planet from the era of epic wars like Mahabharata and Ramayana can be seen on any planet which is the same distance apart as the light has traveled up to now? And a connected question, is it possible that black holes could be the reason of time travel?
हाँ, तो पहला क्वेश्चन ये है कि हमारे प्लेनेट के ऊपर जो कुछ हुआ है टेक्निकली वो फोटोन्स जा रहे हैं, लाइट जा रही है, ठीक है, अब वो जाती जा रही है। अगर सपोज करो उधर वेगा स्टार है, आपने कभी कॉन्टैक्ट मूवी देखी है? अब वो देखना सबसे पहले कॉन्टैक्ट मूवी। उसमें जूडी फोस्टर है एक्ट्रेस जो एस्ट्रोनॉमर बनी है, और ये उस पे बेस्ड है, कॉन्टैक्ट नॉवल पे बेस्ड है जो कार्ल सैगन ने लिखी हुई है। कार्ल सैगन फेमस कॉस्मोस वाला प्लानिटरी साइंटिस्ट है। कॉन्टैक्ट जाके देखो सबसे पहले, ठीक है। अच्छा, आपने अब आपके सपोज करो महाभारत रामायण के सिग्नल जा चुके हुए हैं, फोटोन्स की फॉर्म में गए हैं, सब विजिबल सपोज करो चले गए हैं। वो फोटोन्स कितनी डिस्टेंस ट्रेवल कर चुके हुए हैं? अगर आपने अब फोटोन के ऊपर ही राइड करोगे तब भी आप पीछे रहोगे, क्यों? समझ गए ना? अब मान लो कि आप फोटोन ही हो, आप अपने आप को फोटोन मान लो, वो तो फोटोन आगे चले गया हुआ है, आपका फोटोन अब पीछे जा रहा है। Now there is something known as theory of relativity. Theory of relativity says that you cannot exceed the velocity c. तो वो जो c velocity से जा रहा है, आप c से ही जाओगे। तो ये ऐसे है कि आपके पेरेंट्स घर से निकल गए हैं एक स्कूटर पे जो मैक्सिमम स्पीड 60 किलोमीटर पर आ रहा है, वो 1 घंटे पहले निकल गए हैं, और आप अब निकल रहे हो 1 घंटे बाद, वो भी 60 किलोमीटर पर आर, आप कभी कैच ही नहीं कर सकोगे। आपकी अगर 80-90 करो तो कैच कर लोगे, लेकिन थ्योरी ऑफ रिलेटिविटी कहती सी बस बहुत हो गया, सी पे इससे ज्यादा नहीं मैं कर सकता, सी ओके, तो दैट इज नॉट पॉसिबल। लेकिन आप ये कर सकते हो कि वेगा वालों से कम्युनिकेट कर लो भी, आपने देख ली, क्योंकि उनके पास पहुंची होगी। मैं हाइपोथेटिकल बता रहा हूं, तभी कॉन्टैक्ट मूवी मैंने बताई है, उधर वेगा ही इन्वॉल्व है, उसके पास कोई प्लैनेट है, वो कोई है कुछ। अच्छा, अब उनसे पूछो कि देख लिया, अब वो कैसे करोगे? अब उसके लिए क्या करेंगे? देयर इज समथिंग नोन एज वर्म होल, यू क्रिएट ए वर्म होल। एक कॉन्टैक्ट मूवी में वो वर्म होल बनाते हैं, वो कुछ करते हैं उसका। अब आ गया ब्लैक होल की फिजिक्स। ब्लैक होल की फिजिक्स का मसला ये है कि जब भी आप टॉक दो ना, इस तरह की टॉक कहीं पे भी दो, आखिर में आपकी कुंडी जो है ना वो ब्लैक होल पे फंसी जाती है कहीं ना कहीं। अब मैं उसकी एक कहानी बताता हूँ। हम ना बच्चों को पालते हैं, आप जैसे बच्चों को एमएससी फाइनल तक लेके जाते हैं, फिर उनको एक जीटीआर का कोर्स कराते हैं, जनरल थ्योरी ऑफ रिलेटिविटी। देन द लास्ट आर्टिकल इज डीलिंग विद ब्लैक होल। देयर वी स्पेसिफिकली से दैट वी डू नॉट नो द इंटीरियर स्ट्रक्चर विद इन इवेंट होराइजन जो भी है ऑफ ब्लैक होल, दैट फिजिक्स इज नॉट एट ऑल क्लियर, हमारे को पता ही नहीं उसकी फिजिक्स क्या है। अब आपका कर करा के क्वेश्चन का मतलब ये बना, मैं कहूंगा मेरे को फिजिक्स नहीं पता और किसी को भी नहीं पता ब्लैक होल की फिजिक्स। इवेंट होराइजन के बाहर यू अंडरस्टैंड व्हाट हैपेंस विद इन इवेंट होराइजन, द फिजिक्स फ्रैगमेंट्स, एट लीस्ट द फिजिक्स विच वी अंडरस्टैंड। सो द आंसर इज नोबडी नोज। टाइम ट्रेवल करोगे, अब मैं एक और मूवी एडवाइस करूंगा आपको, इंटरस्टेलर। इंटरस्टेलर में उन्होंने बड़ा अजीब सा करा हुआ है, आखिर में वो कहते हैं कि लास्ट में प्रॉब्लम सॉल्व कर ली वो साइंटिस्ट ने, भागती है वो यूरेका करते करते। अब मैंने वो इतनी बार मूवी देखी कि कुछ तो ये हिंट दे दें, क्योंकि वो बनाई भी इन लोगों ने है, वो कुछ नहीं है अभी, वो क्या ऐसे ही गोल काम हो जाता है। नो, वी डू नॉट अंडरस्टैंड द फिजिक्स ऑफ ब्लैक होल, व्हाट इज देयर इनसाइड द ब्लैक होल। वो जो उसकी जो अगर आपने सुना होगा स्क्वार्ट्सचाइल्ड क्राइटेरिया लेके सब कुछ करते हैं, वो अंदर सारा कुछ नहीं है, कुछ नहीं क्लियर है, छोड़ दो वो। आप ये तमन्ना लेके मत चलो कि आपको सब कुछ समझ आ जाएगा, वो नहीं होने वाला। जो वो है ना, जो मजा इंतजार में है वो विसाले सनम में नहीं। वो है, हमेशा के लिए कुछ ना कुछ रह जाएगा। हाँ, वो करते रहो, वेट करो।
So what is
या
your
कई
name?
बार फ्रस्ट्रेशन हो जाती है, ये क्यों नहीं पता लग रहा, कहीं से तो मेरे को नहीं समझ आ रही, कोई बुक देख लो, कहीं तो कुछ मार लो, मत्था मारो, कहीं नहीं है। आपको पूरी गारंटी नहीं देती फिजिक्स हर चीज को समझाने की, जितना समझाती उतनी समझ लो, खुश रहो।
Thank you, sir. Thank you, sir, for such an interesting interaction and answering all the curiosity of these students. So now I would like to invite Professor Pankaj Jain to present the memento to our speaker. Thank you, sir, again. Now, I request all the winners, all the students whose questions got selected, so come to the stage and take your gift. The gift is the Springer Nature voucher. You can buy the books from there. Using this voucher, you can buy the books from the Springer Nature Flea. So please come and let us give a.
So we have Pundarik from KV IIT, then Siddhi Shri from KV IIT, Rehan from GIC, Arush Tripathi from Kendriya Vidyalaya, Anukriti from KV, Yug Chauhan from KV, Harshit Kamal from GHSS, Arnav Gautam from KV, Drishti from KV. Can we have a huge round of applause for all these winners, please?
Okay, thank you, sir. Now it is time for the break, but I will not leave you without my poetry. So the last 4 lines, okay. So just a question, when you look at the moon, what is that dark thing you see on the moon, what it is called? It is called as mare, M-A-R-E, mare. So with that, मारे देखा पोल देखा, मारे देखा पोल देखा, पूरे चांद का भूगोल देखा, घटनाक्रम को जान रहा, मैं क्रेटर छान रहा, मैं मानव की जिज्ञासा हूँ, मैं वैज्ञानिक अभिलाषा हूँ, मैं भरत भूमि का कीर्तिमान हूँ, मैं चंद्रयान हूँ, मैं चंद्रयान हूँ। With that, we have had a productive and engaging morning, and now it is time to take a well-deserved break. After lunch, we will meet again at around 2 p.m. in this hall, and we'll start with the panel discussion session on India's contribution to advancement in space sciences. Thank you.
Just a few announcements to make. I request all the students to exit via the right gate and the rest of us to go via the left one. And for the students who have registered, please collect your lunch tokens from the registration desk. And the lunch will be served in the L9 foyer where we had the tea. Thank you.
Good afternoon, everyone. I hope all of you are having a great time. My name is Ananya Gudenia. I am an MTech student at the Space Department, and I welcome you all back for the post-lunch part of the event. With much of the credit going to the ISRO, India has quickly emerged as a global leader in space technology and exploration in just 6 decades, sorry. An outstanding example of ISRO's achievement is its track record. Through its historical and magnificent timeline, ISRO scripted numerous technological breakthroughs and initiated the launch of indigenous spacefaring entities. These hallmarks, ranging from the maiden flight of Aryabhatta in 1975, which marked the country's entry into space travel, the launch of Rohini satellite in 1980, which cemented India's position as the sixth spacefaring nation, the spectacular success of the Chandrayaan lunar venture in 2008, the Mangalyaan in 2013, which further cemented ISRO's status as the fourth space agency to reach Mars, and the Chandrayaan Mission 3, which dared to navigate the challenging terrain of the lunar South Pole. But why hear it from me when we are in the presence of such honorable people who have directly played a major part in the development of growth of space technology in our country? I request you all to welcome my esteemed panel members. First off, I would like to welcome Professor Manish Chandra Uttam, who is a director at ISRO UOP Space Technology Cell at Savitribai Phule, Pune University. Next, we have with us Professor Ajit Kembhavi, who is presently a Professor Emeritus at the Inter-University Center for Astronomy and Astrophysics at Pune, which he was also a founder member. Then we have with us Dr. Amitesh Omar, faculty of the Space Department, and finally Mr. Tushar Jadhav, co-founder at Manastu Space. Please give them a huge round of applause.
Okay, so I think we can begin. I'm just putting the things, the titles and what is the aim, let's say, of this panel discussion. So on this National Space Day, there are a couple of things we have been, asking by ourselves, and also in the department. Sometimes the questions come from students that if they, want to join the space science and technology areas, what are the future prospects basically? Now, that's a reasonable question when students enter IIT or any other engineering institutes, that after 4 years, 5 years, or after doing the MTech, where they can be finding jobs, what kind of work is required, and what industries, as well as the government as well as the non-government things. For example, if we only have the ISRO, then of course the employment may become limited. But as we have been hearing from many discussion, that a lot of startups are coming, lots of industries are coming. So what are the roles? This thing. Another thing I think we should be discussing is the opportunity for the regional growth. I mean, it's very clear that there are lots of industries in the southern part of the country related to the space, technology. Some are now coming up, as we saw one stall outside, which is right in the IIT Kanpur, the startup, right? And so what can be actually done that, the governments, for example, can support setting up industries in this part of the country? What are the requirements, or how can we actually proceed? Certain suggestions can come from the esteemed colleagues and experts sitting here. And then we can actually have questions from audience, that what do they expect, what are their queries. So with this, I would like one by one that if the esteemed colleagues make some remark. So may I start with Professor Uttam?
Yeah.
Please say something.
I think there are few things which we should try to correct it. We had heard very interesting talks this morning. I wanted to share some of my personal experience in this field. One is what I find lack of interest in space-related research activities among our fresh engineers, fresh scientists who are graduating or post-graduating. For them, that interest has not been created sufficient to try, I want to go to this field. Number one, I will elaborate something more. Second thing, which is more disturbing, is lack of utilizing the information what we gather from our satellites. For example, we have more than a dozen remote sensing satellites all the time orbiting Earth. And they are transmitting data about our cultivation, agriculture, forest, water, so many things. But really, are we able to make use of that data in a practical way? In the early stages, we can say yes, it is difficult because data has to be interpreted, it has to be communicated. But now we are at least 20 to 30 years since we are having this sort of satellites. But even today, real users are not getting timely information. This is, very just recently, few years back, we had tsunami. After the tsunami waves, lot of damage was there. Then we came to know that satellites had captured in the initial stage of the development of tsunami. Had this information been received by the concerned people, significant damage could have been prevented. But we could see beautiful photographs of these sea waves, how they are getting formed after 24 hours. That time perhaps we were not ready. But today, are we ready? Still that question comes. Last month, there was a big, landsliding in Kerala. Lot of damage is done. Did we not get enough indication that it is going to happen and we could have even? It all shows that really we are not in a position to take advantage of that information. And that is where these institutes, Department of Space, newly opened here in IIT Kanpur, or many other institutes, can play a very important role. How to train more number of people who could be able to read this information and be part of the system. That is one my suggestion, that the data available, how to utilize it. Now I'm coming to the point number one. That is, I consider very important, because unless we motivate our bright engineers to look this one. We have done this work among the physicists. They are getting interested about atmospheric sciences, about astronomy, and like IUCA, etc. They are doing wonderful work. Lot of PhDs in physics, they are attracting and doing that one. But on the hardware side, on the propulsion side, I think there is still a lot of things to be done. I find IIT's graduates who are coming out, whether he is mechanical engineer, aerospace engineer, or electronics or control, his first preference is either go for MBA, do management. Second preference, go abroad, do his MS. And very few people will be interested to join DRDO or ISRO, where these activities are there. What we should do to motivate, tell them there is so much scope for doing R&D. I am a chemical engineer. I was involved in the development of solid propellant. What it pains to me, the propellant formulation what we developed 50 years back in early 70s, we are using same oxidizer, same binder in our present GSLV Mark III and PSLV rockets. In 50 years, we should have looked for more new propellants, green propellants, more energetic propellants, this one. So there is a scope for chemists, for chemical engineers, for mechanical engineers to look for that. But this is not. Similarly, very recently, that problem in the space about the helium leakage. There is a mechanical system. Why it should leak? We should overcome on all. So we need to have fresh ideas. And for that, we need our bright graduates who are coming out from institutes like these IITs. They should be motivated that, yes, there is a scope for doing something like that. These are the 2 points what I thought I would like to share. Then maybe after hearing something more I can say.
Thank you. Yes. So may I proceed with the question?
Yeah.
Yeah. Thank you, sir, and thank you for the opportunity in inviting me here. So, I'm always love talking controversial. So, sir, I don't agree with your first point. As a senior ISRO scientist, I'm saying I don't agree. I'll tell you why. For a simple reason, there are actually a lot of interest in the space industry we are seeing. I myself, when I graduated from IIT Bombay 2014, that time in India, if you have to do the space, apart from ISRO, there was no other option. Okay. Unfortunately, the larger industries, in terms of main core development research, options were much lesser, and that's where the people like me and the people who are doing it, we took the baton saying that we will invent. So problem was at a very different level. So someone had to take that risk at a imagining level that was needed for the tomorrow. So when we are seeing a people also, the fact that people are interested, the fact is that because the people are here talking to hearing us on the Saturday afternoon, when it is ideally the holiday. So that is the testament that people are interested. So now, but if you are studied in the IITs and if you don't get into the ISRO and DRDO, then you probably didn't have the option. And people may or may not be because someone has done the IITs and IITs with their loans and all those things, family expectations, so it was not possible for everyone to work in that government setting. So other industry, it is my job and other fellows' jobs to create a job which are high value, so that we don't have to just negotiate in terms of salary, in terms of working, asking them to work with the lower standard that what they would have gotten into, say, banks, but parallelly fulfill their passions. Whoever 20, 30, 40% people who are passionate to continue, give them that opportunity. So they should not have to choose between the passion and the money. So how can we do that both? That's why the lot of government funds, the startup investments, those are the options. And people here sitting in, what the sir mentioned, the second problem is the business idea. And if people in this room can't do that, then who will else do it? I mean, of course, other people will also do that, but this is a chance for us, people sitting here, to do those things. So if you see someone telling problem, you're always, the light should go in your head, oh, it's an opportunity to make money. And when I say make money by building a great product. It should never be that, oh, I don't want to talk about the money. You should talk about the money. And in the process, by building a great product and service, and exactly the problem was sir was mentioning. The second problem sir mentioned is real problem. So can you give the real-time information? I don't care about the data from satellite. If I'm a user, I frankly has no value of a data. I have a value of insights. So value-added service is very important. So by sending some 10,000 images, what will I do with it? If someone can build it at the click of those things, like what my WhatsApp messages are available, can I do that for the images and information insights also? That's a business idea. So you need to learn, read between the lines, and that's why this is the time, especially because every time we, Subbura sir and we are going through the exhibition, whatever the technology was shown, for us as a businessman, we see the product and the business opportunity. So we are telling like, you are already doing that part, creating the technologies and the jobs for tomorrow. So think in that line. And that's where you should not stop dreaming about what are the potential possibilities. When we started in terms of space in 2016-17, there was no space. There was very hardly one single digit startups, no investor investing. Now times are much better. So that's where you come into the picture. So can you grab this opportunity and build something amazing where you create a job for other people to the value that they are pursuing their passion and they are being paid at the best possible standard. So that's how I see the role of academia working very closely with the industry, because the topic is in that way. So without IIT Bombay's support, I would not have been possible. Because we work very closely with initial 4 years in the campus. Our journey started when we built a satellite in university called Pratham IIT Bombay. We got an experience of building hardware that time. And then initial 4 years of our startup, we were in IIT, using IIT facility. And then we set up our own labs, and once we had the investment. So that's where that's why when I see all the technologies, I see the opportunity. So that's where now I'm willing to collaborate with the professors here and work with the students to take those products to the next level. So that's where the startups, academia collaboration, industry academia collaboration makes a very, very big effort. Without Stanford, there is no Silicon Valley. Very simple. Silicon Valley is because of the Stanfords. So you need to understand. And that's why the academia industry role plays a very important role, especially for startups where the core is the innovation product, especially for the space sector. So that's what I want to see here. So, and there are jobs. Let me tell you the other way around. There are a lot of jobs. The problem is the skills. So if we can have the people with the skills, the jobs are there. So industry, startups are looking for it. And if you talk to every founder, one of the major worry is either the customer or the people. So skilled people who can start delivering, working with them, and start thinking more in terms of what the founders and the team knows. More than that, can they start adding value to that level? So those people is definitely what needed. Of course, early stage also, little bit experience also, and highly experienced also. All those people we need, especially expertise in one particular area. So that's where we believe is the next opportunity in India.
Okay, thanks. Sir Kumbhavi.
Yeah, good afternoon. I'm very happy to be here. As quite an outsider to this kind of discussion, because by profession, I'm an astronomer. Okay, and I've been using space data all the time, all my life. Okay, but as a distant user. But I did get involved quite a lot with ISRO. And I was on the Space Commission for a few years, and then I'm on the Apex committees, and therefore I'm very deeply involved in all this thinking. And I once led the committee to call for new scientific proposals and so on. But those developments are there and then they keep happening. And we are all comfortable with them and we know what is in store for them. So if I want to do X-ray astronomy, for example, I have to convince ISRO that they should launch, let's say, the brother or sister of AstroSat. Right? And then I would design the experiment, I can have a very good detectors. That particular line of action is completely clear to me. And who are the young people who will be working on it? And I won't be able to build anything with my hands now. But who are the young people? And there will be people from the IITs, from the ISRs, from the universities, and so on. But now we are talking about a new path. There are all kinds of startups. There are people who are what you would call a part of the industry. And for me, I was looking at all the wonderful stalls which are outside. I'd never heard of any of those companies, but now I know what they do. But for me, continuously, the problem is where is the uptake. Now, for example, he says that they want people like you, but then you, together with the company, make something, and where does it go? And again, there are two clear paths. One path is for the ISRO projects, okay, because for Chandrayaan, for things, and you always need continuous upgradation there for the most basic technology. And I see that people advertise new kinds of nozzles, new kinds of things, that is there. And then the second one, of course, is in the defense sector. But both these sectors are still limited, okay, meaning that that budget is not going to go up very much. And there are a certain number of people who will be needed. But once you have a department in, in an IIT, and then there will be more departments in more IITs, then the number will keep increasing exponentially. And the doubling time will be small in the beginning, but it is there. So what do those people do? And again, the answer was contained in what the gentleman said, is that there's a fantastic amount of data to be used, okay, because the data is all sitting there. So even for a person like me, meaning that I'm a senior person, I've been around for decades, I know everybody, but we were working on a project for getting data on trees in Pune, because we have got the ground data on 5 million trees, and I thought that it would be a wonderful idea to take data from the satellites, okay, and then set up a machine learning thing between data on the ground and data from the satellites, because then the data from the satellites could be generalized to other territories where the ground level data is not available. It's extremely difficult to get the data, even though you know everybody. And having got the data, the pre-processing can be difficult, and then the processing can be difficult. So the people who want to work on the tree projects, like you said, they don't want to get involved in all this, because they have their own issues too. So there is going to be a great deal of demand, first of all, to make the data freely available. Meaning a company can tell ISRO that I act as the intermediary. Okay, you give me the data and I will give to the people, you build the interfaces. Okay, then to make the data palatable. Now the other new issue will still come out, is that once the data is there, that data is being collected at a certain rate. But then you may decide that data is needed at a different rate, data is needed at a different company. And then you say that, look, there's all this technology, there's all these startups, and so why not we build our own satellite? Right, so once you build, because then you exactly design the satellite in the way that you want. And in the old days, you would have been completely dependent on ISRO to do that for you. Okay, but now there are all the startups which can do it, because the ideas are there. Right, so therefore the market will keep increasing. So it is like cell phones. So you see that cell phones were initially bought up by people who were very rich, or people who work for companies which had a lot of money to spend. I know that from personal experience. How rare they were. Okay, you had a cell phone, but who will you call? Because nobody else had a cell phone. Right, then who are the next people who got it? They were not people like you and I. They are not educated people. They are not middle class people. They are the poor people who bought them. Right, because in Bombay, people would just make a call to the bhajiwala, would bring the bhaji to the doorstep. They would actually send a bag down and filled it over with the bhaji. Okay? And then the famous story of the fishermen in Kerala, for example, they get information from using their cell phones about where there is demand for fish of a particular kind. So that can double your income that day. So you see that, and now cell phones are so common, there are so many models there, so many sets, and that itself becomes a growth industry. Right? So which means that when you people start building your products, which are for space-related things, and there are immense numbers of applications. It will not be quite like biopharma. I'm also involved in all the biopharma startups and things. Involved meaning I know people who are involved in them. And then for example, you can make a new kind of yogurt. It just goes off. Okay, just make the probiotics for putting in the yogurt, and your company will do extremely well. That is because there's an application in every little sector of society. Okay, for biotechnology and biopharma. But for us, it is not like that. It is more specialized. But we'll have to push more. But the returns will be great. And another sector which I believe should be pushed very hard is export. Okay, because more and more countries need satellites. And then if you can make it possible that, okay, we will build a satellite for you on order. Okay, and I think that will be truly wonderful, because then it is again a limitless growth opportunity. Thank you.
Yeah, thanks. So I think before we start some more discussion, if there are some questions from the audience.
Any questions or suggestions from the audience?
Questions and suggestions, queries. Then perhaps we can make a discussion on those topics first.
I would like to request somebody from audience to say about my first point, how to generate interest in the field of the space research activities. Any suggestions? What we should be doing? Maybe I think professors can, yes, please. Perhaps, yeah, I think it is a good suggestion we should keep in mind. My point was the scientists, the engineers who are coming out from this institute, from any other engineering college or institute, they should be able to think that these are the areas where there is a lot of scope for doing research work, not just routine production like that. So for that, to spread that knowledge, I think interaction with the institutes like ISRO, DRDO, etc. will be very useful, because they must know what is the scope for doing research work, PhD work. A bright man, he doesn't want to do simply routine type of work. He wants to look for something new. So maybe we should think on that line.
Yeah, so I would.
I think use mic.
I hope I'm audible enough. So, as sir mentioned, I guess for increasing the interest towards cosmology and astrophysics, it needs to be coming from the very beginner stage. So, what could be done, through podcast, through social, because a lot of youngsters are today in social media. So through social media, we can create some sort of engagement towards this field where you guys can, the keynote speakers specifically, they can come up with topics related to cosmology. So it would enhance the interest towards the young crowd, and that would eventually take them to bring up to this stage, and that's what I feel.
Yeah, I think what you were saying related to the courses like the cosmology and the interest where the lots of students have normally, right? I mean, like when the talks were going on, if I understand, everybody asked about the black holes or how the universe things. So that, if I'm right, that's what you're saying, that have some more, right?
So people usually know big terms like black hole and everything, but they don't know the insight behind that. So that is something which needs to come along, actually.
I think that we are talking about something completely different right now. You see, we are, as I said, I am an astronomer, so many other people here are astronomers, but we are really talking of space technology. Right? So one should not mix up the two things. You may use space technology to make measurements on black holes, but there will just be one application. What we are talking about is for those people who are the feet on the ground, okay, and who would like to participate in this very important and new and productive emerging situation. We want to harness space, and that is what we are talking about at the present time.
Yeah.
So one should not, I don't think it would be appropriate to put a cosmology question in the space thing and try to attract young people. We don't want people like that. I'm sure that the IIT, when I look around, it's full of people with an entrepreneurial spirit, and we want to do something. And those are the people that we want to address for meeting this new challenge. Right?
Thank you, sir.
Hello. I just have a simple question regarding the startup company related to space technology and this one. So, like this? Okay. So, the question is that awareness towards startup company related to space technology is very less among the group of engineers wherever we go, because as personally as an engineer, this is the first time I'm seeing that an Indian startup company based on space debris and other things has been formulated in this environment. So if there are more and more outreaches regarding how we can make this space technology as a monetary benefit like there are various companies where people can go join and earn, and also people who are interested in space, they can earn their living using that. So if there is any kind of outreach method, that will be better.
No, first basic thing is you, as an institute, you start calling, I will come. Okay. But yes, good point. So that is what I've been thinking about it, that we should do that. You visit the universities and talk to the students more often. As a startup, that becomes little challenge. For a simple reason, the bandwidth, we don't have that much of bandwidth to actually go regularly. India is a wide country. So how can we create a platform where wider number of people can come together and then interact? That is what also is what we are trying to see that. But yes, your point is valid, especially for the people. So for us, it's direct interest. So you get interested into you probably join Manoj tomorrow, or one of you. So that's direct interest to us also. But how do you do that at scale is what we are trying to see. And online YouTube is a very good option. So LinkedIn is most of the startups are very active on the LinkedIn. So one thing everyone can start doing is at least find out 10, 15 companies in space in India, start following their LinkedIn. You can get a lot of update on that. So someone who is interested can start doing that. YouTube has quite a good bit of content of every startup founder talking about their startup. So you can search it on the LinkedIn also. And then if you are really interested, you can start joining, participating in a lot of the space-related conferences that happens across India. So for that, you can look into the sir is a part of SIA, Satcom Industrial Association. So that group is very active, conducts regular events. So there is another group called ISPA, Indian Space Association. So that is very active. Keep following there's something called the InSpace, ISRO, by the ISRO's agency. So they are into the promotion side. So they keep conducting different events. So these are the 3-4 websites. I can suggest you start following the LinkedIn, the YouTube. You can start getting a lot of input. But yes, this one-on-one interaction is the best one. So we would love at our end also to start doing that more often. So
I just want to follow up on what he said. You see, the very fact that in recent years a space technology department has been set up here in IIT means that somebody feels that it's important to do so. Right? So now you have a department. And now you know that there are people like him, which we did not know before. Right? So you have to bring them together. Now, I recently had this very interesting conversation of somebody, there's a company in London which is into driverless cars. And then they have got lots and lots of funding and they're moving very fast. And then they attended an important meeting in computer vision, etc. recently. So the discussion was whether they should spend their time attending these meetings and learning more about computer vision that they need, or should they be building a product? Okay, how do you balance the two? So it's always going to happen. Okay, I mean, it's very interesting because I had the discussion just 2 or 3 days ago. And so, so the point now is that it is, I think, an important task for a department like space, okay, to make this possible. Like he immediately mentioned LinkedIn and he said this, all that. So what you need in the department is a curator, right? Somebody who goes through all these things, because not all of you are going to do it, and if you spend all your time to doing it, you're going to get bad grades and you're not going to pass. Right? So therefore, let's have these people, curators, okay, who keep in touch with them, who look at it on the internet, but as well as making personal touches, and once in a way you invite them over. And there's a fair number of them. And the IITs together could have events, for example. I mean, all this is not very easy to do, but it's going to be very important in the early stages. So it has to be both to the demand side and supply side, both ways. Right? So let's work on it.
yeah, and I'll give a very simple thing. If you find some work of some startup interesting, find the 2-3 contacts of CEOs, CTOs, and some of the people, and start doing the cold messaging on their LinkedIn. You will find the people are very receptive. The community is much smaller, and you will find the people replying it to your message and helping you in whatever way possible. So community is small, they know that we need to help each other to survive and then thrive. So that can be a one very underrated but very powerful tool to collaborate, to work, to join, anyway.
In the morning, we heard very interesting talk from professor about how universe was formed, what about billion years back and all that. That knowledge is very important and useful. But I think we should also consider about the utilization of the space for our present generation. For example, nowadays there is a lot of thinking about the space-based weapons. They are placed in the space and they can cause these things. We have not done any work on that. India has not made significant progress in that area. In my opinion, there is a need to start some groups thinking about that. For example, what type of weapons can be placed in space, and if they are placed by enemy, how we take care of. You can answer yes, it is defense work, but defense will not be doing research work on that. We need to do research work on that. For example, what type of laser beam will be effective, how to generate that laser beam in the space, in the smallest systems. This sort of studies also form part of the space environment. May not be directly for peaceful purpose, but they are equally important. So I thought some thinking should also go regarding the development of some such devices, systems, what other countries are doing. We are not knowing that much because it is still not disclosed. But should we wait for that? For example, today, as I mentioned earlier, that we had developed solid propellant, liquid propellant almost 30, 40 years back, 50 years back. ISRO or DRDO, they do not want to make change because they want to depend on the reliability. So they continue to work on the same. But that's not right. You need to make improvements, and that requires improvements means research work, doing research. That can be done only by the institutes, by scholars like that. Whether it is material for the rocket case, or whether it is a fuel, or it is control system, or all that. So we need to do this sort of studies, and in that I thought we should include space-based weapon systems also. What type of things can work there, how to take care of that. This also could be one thing. Otherwise, with my pardon to IUCA and all that, we know we are going to learn a lot of things about our origin, stars and galaxy and all that. But that will not be of immediate application. We should also keep requirements, what is going to be required. That is my suggestion. Yes, Professor.
This question is to Tushar. More in terms of skills and employability, a lot of discussion going on that. So if you were to look back upon your own BTech, MTech program, is there anything that you see you would want to change, in terms of in the context of your current role as an entrepreneur and as a CEO of a company? What are the skill sets you think are missing in your employees?
Yeah, very big question. So very important question probably, and we keep thinking about that a lot. So that potentially how the curriculum of say today, tomorrow should look like, and what are the most important when some person is performing the best, we try to see what are the things that enables him to do that best of his work ability. So 3-4 things has come out. So first thing is grades are the least of the things that matters, frankly speaking. I was one of the lowest one, but that's separate thing. So what matters is someone who has the ability to stay with a problem for longer duration, so that they have done it over extensive period of time in the curriculum. So for us, when I see that back and how that has reflected is that we build a satellite, and that project I was joined after first year, and then I was part of that after 5th year also. 4 or 5 years we were continuously part of it. So being in one problem, working with it completely as a mad person, solving that dedicatedly to find out to the meaningful end. So that is one aspect that we see is of huge important, especially if you are solving a deep tech problems, where the problems are not getting solved in a couple of days or 1 month, 1 week of coding. That is not an output. Then you need people who have that ability to stay with a problem, think in a different way, and then actually get it done. So that skill, so someone who has gotten her hands dirty, that is very important. Second thing is someone who can, more than solving the problem, understanding the problem is the most critical thing. In the age of ChatGPT especially, now we are seeing that ability to understand the problem to the first principle level. What is exactly the problem that they are facing? Someone who can get to the bottom of the problem using not the IIT knowledge, but the knowledge that you studied while at the time of JEE is good enough to solve the most of the problems. But ability to drill down that problem to those basic fundamentals issues, that is the second skill we feel that is a very important. Third is, once you understood the problem, someone who can imagine the system working in a larger scope. How will this design change will affect this part? And that's where we were discussing in the morning, the system engineering plays a very important role. In my 4-5 years of IIT, you can remove every other course, because I don't even remember most of the things. But one course that has changed my life is system engineering. And that course came because ISRO was very bullish on the system engineering. ISRO will never entertain anyone without system engineer there in the place. So that plays a huge role. Someone who can understand, even if he design a small part of it, but he need to understand the effect of it on the larger system. If he change the design of, say, injector, how the effect will be on the whole flow path, and then the back pressure, the pressure in the chamber, everything you should be able to understand. One change of a diameter in pipe, what that effect will have it in the downstream of the flow, upstream of the flow in the tank, everything you should be able to understand. May not be able to do those work exactly, but he should be able to imagine, understand that. So the system level thinking is a very important critical skill. And the third skill that we wish, fourth skill, especially we feel that should have been taught is how to do the sales. That is very important. If you're not able to sell, you are doing everywhere, you are doing the sell. Either you are in the job interview, or you are convincing your husband, wife to buy some flat, or you are convincing your kid to not do or do something, or you are selling your customer or investor, or you are convincing someone to join your organization. If you can't do that, sell, not the duping, not the fraud, but the genuine sales, how to communicate. That we have to learn very hard way. And that I wish IIT had taught about that. And basics of the finances, how the finances work. In terms of, we make a mistakes of thinking everything as an expense. You need to start understanding it's an investment, it's not expenses. We think that it is asset, but it's a liability. And unless we don't understand those things, personal finances, the company finances, everything is screwed. So I personally feel more these two things, the sales and the finance, how the money works, how the people work. Once you understand those things, then I think the rest of the technical small here and there, those things, you can do that. So that's not a big problem. So these are the 4 things I think are very, very critical.
Apart from the electronics, electrical and all that stuff, there are 2 things which I want to tell. One is that our basic computational physics skills, that is not quite good. Means we have to really work on that, especially this smooth particle hydrodynamics, fluid dynamics. It's not there in the curricula. Means even in the physics departments, these things are not there. And if you want to do anything, means even if you want to simulate anything, you have to first of all do this thing. So we have to work on computational physics, especially smooth particle hydrodynamics or other things. The other thing is that there are few courses which are totally missing, and it is taken for granted that all of us know that thing. One is financial management, one is legal. These 2 things are not at all taught to anybody actually. They say that you will learn it by yourself. So it's better, even if you have some sort of a crash course for few weeks, it should be taught to everybody actually. These financial management and legal issues. And in fact, I have some other things in my mind, but I will not tell that thing here. But computational physics is one thing. Means if I'm given an opportunity to teach any student, I will say that you learn only computational physics. The rest of the things will come automatically. So that has to be done. Because at this moment, I feel myself, I have a limited understanding about computational physics. And I cannot grow on that. It has to be taught properly. Fluid dynamics and hydrodynamics.
Computational fluid dynamics with basics, backing with the basic fundamental physics, and nothing showing just a colorful stuff. Because the biggest fear is that someone will come up with some colorful things and ask me to take a decision about what kind of dimensions to do. I don't believe those things. I said, back me up with the scientific data, back me up with the analytical calculations, and then I take the number. So someone who have that CFD and all the computation dynamics matching with the physics and then experimental data. Though that complete loop has to be completed. Otherwise, the colorful images I say completely, it's a fraud.
So if I'm just trying to summarize this particular part, that apart from the core subjects that are being taught, let's say somebody does a civil engineering or aerospace engineering or whatever. Now, few things what everybody is saying, that it has to be integrated into the curriculum compulsorily, like say the finances and these things. And I believe that IITs do have all the departments here, right, including, I guess, the management and all that. And I'm personally not aware of whether actually students can do the courses, let's say, there. So maybe we can make this point, in bold, that apart from the core subject, these are the common subjects which also should be given attention to, including what he says, computational, let's say, physics or whatever, computational, skills, right? Okay. You want to add? I mean, anybody who wants to add something, maybe.
No, absolutely right, sir. Because first year we had an economics course, but it was talked in a very dry manner. We never understood why the hell he was talking about marginal return and supply demand and all those things. But once we now understand why it was done. So practical way of understanding the economics, finance, and the sales, and sir was mentioning about the legality, those things has to be there. So, and people has to be trained by doing some work in that area actually, and that those becomes a life skills basically.
And also, I think the large data handling. I mean, I won't really say AI and ML particularly, but at least the large data handling, because I think we started when Professor Uttam said that there is a lot of remote sensing data available, but we cannot create a real-time or near real-time triggers that what is going to happen. And that probably means that we are probably not understanding the data in a fast way, that the speed which is actually required to solve such problems. So apart from the computation, I believe we have to do the large data handling kind of things, right? Now,
just to add one point, so sorry. Another skill that I would definitely love, thankfully we got it through the satellite project, was the leadership. As a people from IIT Kanpur and all the IITs, we are expected to be the leaders. And we will eventually, because we will do the good in the tech, eventually we'll get into the lateral progression is into the management. Unfortunately, the leadership, which is a very fundamental of all the things that is happening, if that is not taught, what do you mean by leading the person who are left to you and person who are right to you? That is another things fundamentally, thankfully we learned through the satellite project, but these group projects, working together, developing something meaningful, those things is the best way to learn those things. Good question, sir. Thank you so much.
Is there anything else which you people want to add? Okay, yeah, we have been asking students, definitely, yeah. More questions from students? Yeah, there's one here.
Good afternoon, everyone. Actually, I would like to take the discussion a little back to what Professor Uttam was saying, that starting fresh after the college, what are the challenges which we face while joining the aerospace industry. So one of the problems which we face is that, for example, legacy organizations like ISRO and DRDO, the recruitment does not happen every year, and if the job posting comes in like suppose it launched in June of 1 year, you get the results after 1 or 1.5 years. By that time, the person who has applied, he might go abroad or go in some other job. He has not much time to wait that long. So I guess hiring can be done more frequently in these organizations. Of course, now due to the startup industry, the situation is much better because even the startups, some of their products are like, there's some core R&D and they're also developing something new. And another thing is that outside, when you see, for example, let us compare the American industry. NASA, a lot of people know what they do because they advertise a lot. Some of them they exaggerate also, but they say that, okay, we have done this and we have done that. That level of awareness is not here. Again, for example, I guess someone who watches YouTube, they'll know that there is a channel called In a Nutshell, but very few people know that there are like other similar channels like Garib Scientist and all, who are at least trying to promote what is happening in India in space. So, little, especially after COVID, on YouTube, there are specialized channels which cover these developments, even on Twitter and Reddit, but it's slowly getting up. The more people do it, the more better it is. So yeah, these are the challenges which we face. From the legacy organizations, like the job openings are not frequent. It takes a lot of time to get a call, like answer back from them. So that's the major hurdle which we faced.
I think I also want to highlight this about the outreach part which you in between mentioned. I think we have to do the outreach very well, even if we know that we have been doing very well in our own books, but it has to be actually come out to the public in form of something which they can understand. So I think this is something I've seen the transition now, and we have been seeing when I was doing a PhD, then we used to say we actually, very few institutes actually do outreach, including let's say the ISRO. But I think we have been seeing now, last few years, that ISRO also is now doing some outreach. I won't say it's really to the level of, let's say, what other agencies like NASA and European space agencies do. But still, it is in the right direction that now things are actually reaching to the public, to the students, that they can actually feel connected with the events. So in that way, I will definitely say that we actually have to do a lot about the outreach, the presentations and everything about our missions, our, the scientific aspects and everything. So anybody else wants to add? Yeah. Sure.
Names coming up frequently in our conversations. I'm sure all of you must be reading newspapers and what's happening in the country in terms of allocation of funding and the policies. Today, the government of India is not at all interested in funding the ISRO or DRDO other than the research programs. Even the DRDO is going to be diluted completely, that most of things are going to move to the private sector. It is not only just a system making, but also platform as a whole. Those are things happening in that. Similarly, in the ISRO also, ISRO only research programs only being funded, and nothing like in operational programs at all. So therefore, all of you students coming from a premier institute like here, I think you should not think of anything getting into a government at all. That's a piece of advice of spending so much time in the government and also outside the government. That's number one. Number two is, I think most of the concern these people seems to be having is on the employment part of it. What do we do after this? Can you get the employment? With that being the question, I think that has to be answered by the institute. We have started certain courses, certain activities, then what's going to be the next step on that? For that, one good thing that's happening now is that, your own director, earlier director moved to DST as Science and Technology, and today the government has been allocated nearly about 50,000 crores for research and development programs. And this program is going to help and seed many other programs in the country into various institutions. So I think that's where I think we should play a key role on that. That's as far as research is concerned. And the operational program is concerned, this country has many opportunities in the operationalization of things. For example, you referred something like maps, etc., Google Maps and kind of maps on that. These institutions in America, they don't look at the governmental support alone for doing that. They see what can be done. What is the new idea and how the new idea can have the marketability. You think about in this direction, then you have a solution on that. See, all of us joined in the government those days because the government was the only employment solution for us, employment provider for us. These days, those people who do not fit elsewhere only will get into the government. Please mark my word. Okay? Thanks.
Thank you. Very good point. Sir, being a veteran in the industry who has seen the government, I am also been ex-DRDO. So I can tell you as much as government is there, but sir's point was that most of the opportunities our government wants to move away from the government typical structure to more research-based structure where ISRO is focusing on the all the scientific mission that Madam was mentioning in the morning, and the regular routine satellite launches and all those things handed over to the industry. And that's a huge efforts are going on. Thousands of crores have been, people are looking to invest from the government side. Even the defense is also very actively. The fact that we are in the, as a startup, we have been called in almost every the bigger function of ISRO and the DRDO both. It's a sign that the industry is, the government is very open to, very open, closely working with the startup, open to work with the startup. So, as a sitting in this location, IIT Kanpur, you should start thinking, how can I be a job generator than the job seeker? And not just the job generator in a way, typical job, but some where you employ the highly skilled people. The lower blue collar jobs, so definitely we need to create more of them. But can we create more high skilled job and in the process create a great companies? Why can't we create the SpaceX and the, our own versions of those things? I'm not saying we want that to replicate, but our own company is doing for the global market. Anything space company, if you're building a deep tech technology company building in India, if you think about only India market, it's a crime. So start thinking globally. So, and the global market, because of the time, the government policies, the geopolitics, how the world is shaping up. This is the best time to be in India, developing in India for the global market. People, no one trusts buying from China, especially the space products. Then the other rest of the Asia, we don't have the capabilities so much. It's all India. Can we do at the cost and the quality that is supreme as the ISRO has set up the standard? And when we go and talk to the global customer, when we tell them about sell the defense product, no, people will ask us questions. Are you sure? Can you build it? How good is it? But when you sell a space product to a space company, they don't ask a question whether you can build it or not. Question comes down to directly about the specifications and the cost and the timeline. Because ISRO has done that one hard way. But now the way is that along with the ISRO, there's so much of opportunity. That's why every discussion is ISRO, everyone is saying ISRO is one of the players in the whole growing ecosystem and probably the huge supporting player. And in the using that player as a parent, ISRO now envisioning that other startups becoming a, when the parents are getting, the kids are rising, so they start sharing the burden of their parent. So the startups see that way that we are sharing the burden of what ISRO is doing for the global greater good. So that's where the opportunity to make money also.
So are there more suggestions? Yeah, there is one hand there. Yeah. I think he's from ISRO, right?
Yeah, I'm Amit Pandey from ISTAC ISRO. So just I want to add a few points in the last discussion. It was the point that how to promote and how to make people interested in space technology and all related things. So just I want to add, from ISRO side, ISRO is having one program, Yuvika, for especially school kids, to promote them and have some knowledge in the initial days so that they can be motivated towards the space. And for college going students and university, I think most of the premier institutes ISRO has collaborated and space technology cell has been established. So from
means from institute side, it should be advertised, and most of the students who are interested, they should be helped, and they should be they should be more related to the space technology cell. They should be given opportunities to utilize this collaborative effort of ISRO, and also in ISRO headquarters one outreach section has been established. So if someone want more information or some help, or if some events are being organized, they can approach to headquarters, and the outreach section is will be helping all the way. ISRO can help to advertise their things, space related things, to the normal or common people or college or schools. So this is the information which I want to share with you all. Thank you.
Sorry. Yeah.
Should we be ending now, I think?
Yeah, there are no more suggestions from the audience. I think then we should be winding up and making some final remarks. We have some questions or suggestions?
Good afternoon, sir. Sir, as Tushar sir mentioned about the globalization of space market and the role of India, how India can play. Like as now we are seeing in the launch vehicle market, SpaceX is the leader because they are providing the cheapest launch cost, and even India is working towards that. But we cannot, as of now, at a very immediate scale, we cannot build a Falcon 9 or even Starship or a better version of launch vehicle. So there are two right now stream of commercializations. One is launch vehicles, providing launches, and providing satellite data to the market. Like, does India focus on something more than that?
I got, so where can India focus on something more than that, right? That's
Yes, like commercializing
so what do you
something.
think? What do you think? Let me put it to you. What do you think? Apart from the satellite rocket, do you think there can be another ways?
Like for example, instead of building big rockets, we can come down to some smaller components to make it.
Why do you think small? Understood. So rocket. So let's move away from rockets because enough rockets have been built. What else can you do? So you are saying the OEM small components to the bigger system. That's okay. That also you can build. I'm saying the major business. Do you think there are another space area that can be disrupted in a big way?
Yes.
Which one?
Like India is also now into semiconductor industry. Okay. So we can build one of the highest efficient computer chips. So not only in space, we can also sell it to robotics, computer, like even NVIDIA is there. So we can provide the raw material, and we can generate more and more income from that. We can invest in space and again build bigger things and better things.
So definitely, see, these are a sector that enables the space. Definitely, you can put a semiconductor, you can put antennas, you can put all the different sides of. You can build solar panels, more efficient batteries, all those things, energy. Those things are definitely are the options. I'm thinking, is there any other way? Satellites, typical satellites, rockets, another sector that is enabling or something? I'll answer in the interest of time. So if you go and see the decadal vision documents, so there is very clear. One is space for the ground. Space for the ground is using the satellite to solve the problems on the Earth using satellite data, communication, navigation, and all those things. Second is access to the space. So the rockets and all those things, propulsion system, all those things part of it. The third interesting vertical that is huge, that will probably be the next bigger disruption that is happening, space for the space. And why is that happening? I'll give very short numbers, some small numbers that potentially you can start thinking about it. And that's how how do we see a future also is in that same line. That's what I'm sharing. So currently cost of launching 1 kg into low Earth orbit, roughly ISRO costs $5,000 per kg. Okay, keep the numbers right. ISRO $5,000 per kg to low Earth orbit. Falcon 9 costs somewhere around $2,500 to $3,000 per kg to low Earth orbit. PSLV weight is the low Earth orbit payload capacity is somewhere around 10 tons, I think, in that plus minus few tons. Falcon 9 is somewhere around 25 tons. There is a Starship Heavy. If you are following up what the Starship is doing, what SpaceX is doing, you know what is the cost per kg to low Earth orbit? Anyone has any idea? Anything else? Anyone else? So to keep in the interest of time, Elon Musk is saying $30 per kg. They're achieving it, hopefully in next 2-3 years. I'm saying let's take one order of magnitude change. $300 per kg. 3,000 current cost, $300 per kg. Do you know when was this kind of disruption happened in the ecosystem? 10 times something cost has reduced by 10 times? Anyone? I'm just giving you food for thoughts. In that direction you can start thinking probably. When internet? Who said what? When? Yes. So Jio, one data, 1 GB used to cost around 100 rupees. Now it's 3 to 4 rupees per day, per GB. Order of magnitude change. What did that do? That enabled a lot of secondary businesses that was not possible earlier. UPI, e-commerce, EdTech, of course FinTech, UPI is a FinTech basically. The most important beneficiary is OTT platforms. All your mobile streamings possible because of the Jio. They did one cost of one service and that disrupted the whole ecosystem. So rather than competing with Falcon 9 and what Elon Musk is doing, can you work with him? Can you leverage the cost that he is looking to disrupt? And then build businesses around that as an enabler for something that is not possible in today's age. So can we do some space manufacturing, bring it back? Can you do some beaming of energy from solar to space to ground? Can you do space tourism realistically? Can you think about it? Can you build a space station, think on those lines? So I'm thinking, giving you the ways of thinking, how to think about the disruption in one particular sector. The satellites will be, then the problem. The people will launch large number of satellites. Then there will be another sectors of problems in terms of sustainability in space. So idea is this, start seeing the pattern. And once who can predict the future is someone who can read the history. Someone who understands the history can predict the future. Winston Churchill very famously said, the farther you know the history, farther you can predict the future. So how the ecosystem has disrupted in the last 20 years, you read about it, what is the critical point, and then so that you can do the extrapolation to the next 10 years, 15 years, 20 years. And that's the business idea for you. So I'm just giving you the ways to think about the businesses, what can potentially happen in the space in next 10, 15 years.
Okay, I think with this, I request panelists to make closing remarks, comments.
Yeah, the take home for me from this very interesting discussion has been that it is going to be incredibly important for the Department of Space to have continuous communication with the receiving community, okay, which is the startup and in general the space industry. And I believe that that should be made an integrated part of the activities of the department. It is not going to come out of just organizing one meeting every 6 months or 3 months. It has to become a part of the thinking of the department. So you'll have to employ a couple of people, 2 people, 3 people, who have one foot in the academics and who are willing to put the other foot in the industry and will remain with you and do up the connecting. And if that happens, I believe that there really will be a phase change in the thinking, and it will be an extremely pioneering way of bringing space to the public. And then other thing which he has been emphasizing is that you have to see how all your actions get monetized. So because this is not research at all. Okay, this is applying your brains and your research, okay, for achieving something which is spectacularly new. Okay, like reducing the cost of launch to $30 a kg. So I think that the change in thinking is going to determine whether it will be just an ordinary good department or whether it will be a spectacularly new kind of department. Thank you.
Yeah, just so long story short, there are a lot of interesting opportunity in the ecosystem in terms of A, starting your business, B, if you want to join, Manastu is hiring. So my first name dot last name @manastuspace.com is my address. So if anyone is interested.
I think we had good discussion and some suggestions which came from the audience. They are well received, and maybe next attempt we'll have more positive comments on our progress.
Thank you. So I think we will close the session now, and I express my thanks to all the panelists for giving time here and sharing their views, and also the audience who attended this. Now I would actually say that, as Professor Kimavi has said, to have a continued relation between the academia and industry. I think we can continue this anytime any student, want to put suggestions or something. I think they can approach any of the departments who are closely associated with the space, things. It's not just limited to Department of Space and the Aerospace, but also many other departments in IIT. And I think let's collect all those things very quickly and proceed in the right direction, as we think is the need of the hour at this moment. So with this, I thank everyone for participating in this discussion. Thank you.
Thank you everyone for your questions, and I once again thank all the panelists for sharing their valuable insights with all of us. I now request Professor Kamath to present our panelists with the mementos. First we have Dr. Ajit Kembavi. Next we have Mr. Tushar Jadhav. I request Professor Jain to come on the stage as well. Next we have Professor M.C. Uttam. And finally, Professor Amitesh Umar. Can we once again have a huge round of applause for all our panelists? We have the results for the poster presentation with us. Firstly, I would like to thank our esteemed judges, Professor Tufan Kumar Goha from the Aerospace Department and Professor Kartik C. Sarkar from the Space Department. I request you to kindly come up on the stage and present our winners with their prizes. So the first prize goes to Tanya Krishna Kumar. The second prize goes to Mohit Pawar. And the third prize goes to Jatin Bansal. I request Professor Pankaj Jain to present our judge, Dr. Kartik C. Sarkar, with a token of appreciation. I would like to thank all the people who have put up the stalls outside in the foyer for such informative and wonderful exhibitions. I request one person from each stall to come up on the stage, and I also request Professor Kamath to present them with a small token of appreciation. The stalls we had outside were the Dream Aerospace, next we have Manastu Space, Anant Technologies Private Limited, Skinomat Private Limited, Shiksha Sopan, IITK Rocket and Space Exploration Team. Space Dynamics and Flight Control Lab, Department of Aerospace Engineering, IITK. Seeing the Unseen Schlieren Imaging. And lastly, Spectral Odyssey, the hidden world of light source. And with that, we had one more stall by SRSRC. Okay, so moving on, I would now like to request Dr. Sharvari Nadkarni Ghosh for the vote of thanks.
Hello, thank you everyone for coming to this event today. It is a really nice experience for us. This is the first time the two departments, space as well as aerospace, have come together and put this event. We hope that we will have this as a recurring annual event. And this is the first time we have also established this relationship with the industry, which we hope to foster, and that I hope that this fosters more collaborative efforts in the future. So I would like to thank, firstly, the guests, our chief guest, Dr. Subbarao Pauluri, for the welcome remarks, Srimati Nigar Shahji for giving the keynote speech, Professor Sandeep Sahijpal for the excellent and motivating public lecture this morning. It was really nice to see so many school students here. Sorry to interrupt. We have forgotten to give the memento to one other stall, which is the ISRO.
ISRO Center, please, Mr. Amit, please come on the stage.
Apologies. It's only our first time. Yeah, okay. Yeah, so continuing, I would like to thank Dr. M.C. Uttam, Professor M.C. Uttam. He's the director of the ISRO Pune University ST. Professor Ajit Kimbhavi, this is for, hello. On again. Professor Ajit Kimbhavi, who is the distinguished visiting faculty of the Department of Space, and Mr. Tushar Jadhav from Manastu Space for giving their valuable time and being here and gracing this occasion. I'd like to thank all the teams who put up stalls. Without their support, this thing would not have been possible. The exhibition is really nice, and they'll still be on, so if you have not had a chance, please do go and see them. I'd like to thank the judges of the poster judging of the poster session, Professor Karthik Sarkar and Professor Tufan Kumar Guha, and also Springer, who very generously has sponsored the prizes for the poster presentations. I'd like to thank the LHC staff for providing this venue as well as the audiovisual support. And I would like to thank definitely the two heads of the departments, Professor Pankaj Jain and Professor Gopal Kamath. Without their support and help throughout this organizational effort, they were all the time with the team. I'd like to thank all the student volunteers. They are primarily from the Society of Aerospace Engineers from the Aerospace Department, as well as students from the Department of Space, and the undergraduate students from the Astronomy Club. So all three teams of students have helped put this effort. Thank you to the audience. And last but not the least, I would like to thank Tejpreet Kaur, who really has put in a lot of effort. It's her hard work, perseverance, and organizational skills that have made this event possible today. So please give a big round of applause to Tejpreet. I would like to invite here. Please come. Please, please, I think you should be here. I think she really deserves a big hand. So, and as I said, that this is just the first time this event we have had this event. We hope to have many such events as well as more partnerships. And one of the outcomes of this event, since ISRO and all the other organizations want deliverables, the one deliverable that has come out of this is that we are going to go ahead and sign MOUs with industry. And that has just happened because primarily through this interaction. So I think that's a very, very great outcome of this event like this, because we've really managed to connect to the industry, and we hope to have many more fruitful partnerships in the future. All right, thank you. But I think the day is not over, right? There's still more to come. There's the observational session. Oh, because of the rain, sorry. Okay. So next time we will do it when it's better weather. Okay, thanks.
Thank you, ma'am, and what a great session we have had today. India's space journey, the research began somewhere in the 1920s. These studies were conducted by the then scientists of India, S.K. Mitra, C.V. Raman, and Meghnath Saha. Scientist Vikram Sarabhai played a major role in the establishment of the Indian National Committee for Space Research. It was only within a year after the formation of this committee that India did its first rocket launch in November 1963. The Indian National Committee for Space Research transformed into what we now call ISRO in 1969. Since then, people like Homi Bhabha, H.G.S. Murthy, Vaman Dattatreya Patwardhan, Dr. APJ Abdul Kalam, and many more have played a very significant role in the initial stages of space research in India. Today, we have all gathered here and are in the presence of current flag bearers of the advancement of the space technology. We know the how it began and how it's going, but what's next? The next step is us. We as the young minds, the curious students, ready to learn and take challenges, should now work towards taking things further, because the sky is not the limit anymore. Thank you everyone for joining us today and making the event a huge success. Now we were supposed to have the solar observation, but due to bad weather it has been cancelled. However, we will arrange the session another day for everyone. And thank you everyone for joining us today. We still have the high tea.